Hello, good morning. Manjunath sir, have you joined, sir?
Yeah, I joined. Hope I'm audible, right? Hello.
Yes, sir, you are audible.
Okay, thank you.
Am I audible, sir? Manjunath sir?
Yes, you are audible, sir.
Okay, great. We'll start the session now, sir.
Yeah, sure.
Just introduction.
A very good morning to everyone present here. I'm Basha from 6th semester CSC department. It is my pleasure to welcome you all to the session 7, day 3 of the 3-day faculty development program on AI and machine learning from healthcare engineering, which is being conducted at New Horizon College of Engineering. The topic for this session is depression prediction using ML technologies. And our speaker for this session is Dr. Manjunatha Annappa, AI software engineer, CV R&D, Detect Technologies, Chennai. He has completed his MCA, ranking first with a gold medal from Central University of Karnataka in 2021. He has about 2 years of professional experience. He has resolved several complex real world problems, including the aerial identification of a person's uneven activity, which is also known as drone view, person identification in real time using a sketch image for CBI. Additionally, he has also worked on a train blast detection and also did research projects in the area of facial recognition adaptive threshold. And now he is indulged in a study looking at the role of food in maintaining BMI. His achievements include Ace of Innovation Young Scientist Awardee in 2019, Smart India Hackathon 2020 finalist, presented 2 journal papers on Springer and 2 conference papers, and also, as a resource person, delivered more than 20 lectures. Sir, it's a real privilege to have you here, and I request you to start the session.
Yeah, thank you so much for the introduction, sir. And first of all, I need to thank everyone from the New Horizon College for this opportunity. And let me share my screen. Please confirm in the chat whether it is visible or not, if possible. The screen is visible?
Yes, sir.
Yeah, I hope. Okay. Yeah, good morning, folks. Uh, Depression prediction is the topic for the one of the, like, I can say, one of the important topic where we are lagging in research. So why and what is the importance of this application, and where we need to focus more to solve this kind of depression kind of issues. Like, let we explore all these things one by one in this particular session. Okay. So, what is session outline here? So, what are all the things I'm covering in this particular session? Better, 1 minute. Let me turn off my cam. That will be a better option. You can clearly view my screen. Yeah. Okay. Yeah, what are all the things I'm covering in this session is the first thing is what actually the depression, what are all the factors which will influence on depression, and why the AI is better over the traditional depression prediction mechanism, and how we can understand the data, how we can clean the data, how we can analyze what are all the important key factors are there in the particular data set what we have. And finally, once we analyze the data, I mean, once the EDA is completed, we will go further in the in the data modeling. So, what kind of data we have, what kind of algorithm I need to use, uh, how we can say that this model is working well on this particular data. These all things will be covered in the data modeling section. And the one of the very important thing as a techie we should know after graduating and all, how we can handle the depression. Because college life, it is it's having its advantages, and it, like, you can, for example, if you have 4 or 5 chapters, you can skip at least 1 or 2 chapter. But as a techie, in a project, you can't skip anything like that. So how you can handle the depression as a techie, how you can handle the depression as a student, I will explore all these things apart from the technical things. This is very important, I thought, so that's why I'm covering this one. So these are all the session outline. Let's jump into the topic. Usually, nowadays it's a common thing, right? Like, when if you ask any people who is in saddy mood, like, oh, why are you sad? He used to say like, I'm in depression. Actually, is that the depression, or is that is just a mood? In a simple word, I can say that if you are feeling sad for a particular reason, then that is not actually a depression. If you are feeling sad for the reason for a long time, I mean for a 15 days or for a month, then I can say depression. But the keyword here is you are feeling that particular sadness for a particular reason. That is what actually the depression. So many people, like many of them, don't know about actually what is the depression. So as Wikipedia says, the general definition of depression is a common mental disorder, okay, that affects of million of people around the world. It is characterized by persistent feelings of sadness, hopelessness, and loss of interest in the activities. In simple word, they don't have any hope in their life, and they lost all kind of interest in the activities, and they used to feel like I am alone, no one is there with me. So why they're having these kind of feelings? What are all the things actually it is affecting on? The first one, why the people used to feel depression, is genetics. The important thing about this is, like, if your forefathers are like grandmother and mother, like, usually why I'm saying grandmother and mother means, as study says, most number of females are facing the depression issue. So that's why it is, like, the probability of occurring the depression is more from the mother side. Okay, and even it's possible that it will be affected by father side also. But the most of the study states, including mother genetics, it may pass from one generation to another generation. The second one is brain chemistry. It is not actually your fault. uh, Hope I'm audible, right? Sorry, there is a power connection issue. uh, am I audible now?
Yes, sir.
Yes,
uh, s- yeah, actually where I left, if anyone can say, like, session outline, I don't know when it disconnected. In the session outline, or like in the introduction of the depression?
This one, sir, genetics, including genetics you were talking about.
Yeah. Then the next thing is like brain chemistry. So if you're facing any issues, like chemical composition in the brain, then it may also affect on uh, depression. And the important thing you need to focus on is life events, because currently what are all the things we are following in our daily routine that may affect on like our health, that kind of mental health. Because of affecting on mental health, we are facing this depression issue. So you need to make sure that your life events will be in a particular way where you need to focus on improving your physical health as mental health. At least you need to spend some times on physical workout, and you need to listen good music. These kind of things will make you sure that you are a healthy person. So life events will also matters when you feel like some depression. And medical conditions, as I said, like different medical condition, you will get to know about this different kind of medical condition when we are going through depth of the particular topic. Okay, so these are all the important causes. Apart from this, several things are affecting on the mental health. So these are very important causes. Okay, why I selected this topic? This is interesting one. You should know these things, because as per statistics, when I present something, then only you will understand why this is very important. So I divided into two part. The first one is what actually the depression going on with adults and depression with the children. So let's focus on depression in adults. I hope all you know about like World Health Organization, WHO, right? So as per WHO, depression is the leading cause of disability. Okay, it's one of the leading cause of disability around the worldwide. And WHO estimated that around 264 million people are affected by depression. So 264 million people means this is not at all small amount. Okay, let's come into our Indian population, how they are. So around 4.5% of the Indian populations are suffering from depression. 4.5 means around 140 crores we population we have. Around 6 to 7 crore people are suffering from depression. And as I said, women's are like twice as men experience depression. Means the uh, I mean the depression experience is more likely comparing with men. Women are having more depression feelings. And the people one who are facing the depression, right, nowadays the depression people age is between 18 and 25. People between this age are facing so much of depression. Why? And what we can do, this is important thing we need to focus. This is about adults. When we come with children's, you can see that like WHO, as the survey of WHO, 3.2 million children aged from 3 to 17 years in the United States have been diagnosed with the depression. Think. And children with the family history, for example, like as I said, if your grandmother or mother having depression, then definitely it will affect on the child. And in India, we can say 4.4% of the children aged 13 to 17 years are experiencing this depression. I mean, like, this is huge number, right? As a child, we can't ignore these facts. And the bad thing about depression is, in the age between 15 to 19 years, right? Many people are committing suicide because of the depression. And this is the depression is the third leading cause of death. I mean, suicide. So think how much it is affecting on people's life. That's why I selected this topic, where we can use our artificial intelligence machine learning technique to solve this problem. And why we need ML techniques to predict the depression. Why we need why actually the traditional system is failing to detect the depression. The thing is, the traditional system what we have, it will take more time for analyzing the things. I mean, why this person is having the depression, and like what are all the reasons, how we can the process of detecting is right. It's a huge, time consuming process. And after that particular person, curing them will also take a lot of time. So in this time span, sometimes the people who are facing depression, they can like they can feel some another level of pressure, and they can lose their lives also. So this is one of the important thing. And uh, why we are using AI and ML techniques to solve the issues in real world, which using cost effective techniques, and like more expertise technique. And the very important thing is, like it will make our life cycle in a better way, right? So that's why the ML technique, it will overcome the cost effectiveness of the I mean, the traditional system is not actually cost effective, so it will overcome that issue. And sometimes if you will go somewhere and the doctor is not expert in that, the psychiatrist is not expert to resolve your issue, then that is also a issue. So a traditional system is having lack of expertise, and cost effectiveness is also a matter, and the process is very slow. So that's why we need to go with ML techniques. So why this depression prediction is more sensitive, right? Because the simple thing, if you made any as a developer, as a data scientist, or as a particular software engineer, if you build some system it is not affecting on people life, it is not giving some positive things for the people life, that it is waste, right? That is one thing. Second thing, if you build something which is directly affecting on people's life, like they are having, depression, but it is not predicting that particular person is having prediction, so sorry, depression. So this is also a issue. To overcome this issue, what are all the things, sensitive things, the developer should have? The developer should aware of the data. Okay, like this is because if the person is don't I mean he is not aware about what actually the data is, what actually, as a data scientist, if you don't know how to handle the data, then that will be an issue, right? So like that, if the like if the particular person is not aware of data, as well as if you have lack of data, and if you are failing in analyzing the data, and if you're failing in implementing the methods, these are all affecting on the particular model or particular product you will create. It will directly affect on the people's life. And what are all the steps we follow to solve this depression prediction problem? So first we collected the data, and then we cleaned the data, and we did exploratory data analysis. Once that is done, then we went to model building with different algorithm. Then particular models will having some issues, right? Whether the hyperparameters parameter, like we need to tune it for better accuracy and better uh, you know f1 score. So we trained that with the better hyperparameter tuning mechanisms. Then we did model evaluation things. Okay, these are all the steps we followed: collecting data, cleaning data, EDA, model building, hyperparameter tuning, and model evaluation. These steps are common for any machine learning model. So about the data, what we have collected, it's a data from, you can see that, Center for Disease Control and Prevention, National Health and Nutrition Examination Survey. It's a US based organization. You can see that link is also there. Like I will explore these things with you in future slides. And the particular thing you need to remember is this data is about to release every 2 years. Okay, it's completely about the mental health, about the people. Okay, I will explore those things. And the thing what we have covered is, like if we screen the people, then the people should have, I mean, why I'm saying these things to correct that error. Okay, so here also we are getting around 0.82 of our AOC value. Even make it zero, true positive and false positives, because it is by nature, like you can get the model like that. But for better sake, if you have good F1 score, then that will be better. And AUC is 0.81. So once we apply grid, then you can get 0.82 with better F1 score. This is very important thing. Then we will go with standard scaling. Why we did standard scaling means we are applying base models, so that's why. Here also you're getting same things, but AUC is decreased. Even after applying the grid, I'm getting this AUC. So then we will go with stacking classifier. Oh, you should aware about this stacking classifier. Okay, this is one of the important thing you should remember, because base model is there and meta model is there. So base model will produce some output, and based on that output, meta model will produce a better output. That is what actually stacking classifier. So it's having great. Then again, I'm training, so I'm getting some good values here. You can see that, but F1 score is not more than 0.37. So like that, I am processing. So then voting classifier, actually voting classifier, you can say that which is having a number of vote, it will take that classifier. So there are two kind of classifiers are there: hard vote classifier and soft vote classifier. Where is the soft vote? You can see that hard vote classifier, what it will do, which is having a number of vote, that will take that particular thing. In soft vote classifier, what it will do, the class average of the total, I mean, if you are taking the total number of which is having majority of the voting, then that is hard one. If you're taking average of the majority, then the probability of majority, then that is soft classifier, vote classifier. But here also I'm not getting that much good accuracy. So then I will go with non-tree models. Then again I will do soft vote and hard vote. So like that I will process. So at last what I get to know is SGD classifier using standard scaling will working in a better way, and I'm taking this one because that will identify over 80% of the negatives and 72% of the true positives. So that's why that model is better one, I can say. So now just this is implemented with this approach because it's complete research one. Now what is the conclusion we can say, like what are all the important factor which will affect on the depression? The first one is here what you can see, right? This left side, this will not affect. This is uh, this is not affecting. These parts are very much affecting. So you can see that marital status will not affect. Moderate recreationness, if they are doing sports and all, that will not matter. That will not affect that much as per the data. Gender will affect. If they are not working, that will affect. If they are having memory problem, that will affect. And one who are facing sleep history, they will face a lot of depression issues. So this is one of the method. Even this is with the feature names with the coefficient value. Here you can see that trouble name, memory, can't work, moderate, creation, no, gender, limited work. You can see that the person one who here it is affecting, here it is not affecting. The difference simple is, if it is yes, then it is not affecting. If they are saying like I'm not playing any game at all, so definitely it will affect. They can't work, yes, you have to be, you will be facing like, you will be in the case where you feel, where you will feel high number of depressions. So like this. So yeah, tough feature. Yeah, this is about like after the one, like I understand like what are the important things, memory, how it is affecting. You can see that memory problem, how much it's affecting. So these are visualizing things. So in a session you can understand the brief view, but in depth if you want to understand, you need to do some research on this. This is one of the important area. So you can see that age by differentiation. So here the age between 45 it's very high, when age go down like it's very less, like this education with one. So yeah, this is what actually the thing we can apply for different algorithm, how we can see the things. And now jump into this part. As a techie, how you can handle the depression? So you need to have a proper sleep. Without proper sleep you can't work, that pressure will be very high. And you need to go with regular workout, at least do some jogging, walking, to around 1 hour per day. And you need to have proper food. Okay, I will suggest consume more liquid food, that will be better. Yeah, and it depends upon the climate also, so where you belongs and what is the circumstances around you. And always you should have positive mindset, it will overcome all the issues. And these are all the reference I used. And yeah, thank you so much. If you have any question you can ask me now.
Thank you, sir. It was very good presentation. Participants, if you have any queries, you can ask to sir. So the participants have asked like, can you share this code or link or PDF, sir, at later
Sure.
stage?
Sure. I will share it with you people. But I need to do some pro work. Like within next week, I will share it with you
No
because
issues, sir. No issues, sir. You can share with me so that I'll forward to participants, sir.
sure, I will share it with you people. Yeah.
We have one more query, sir.
Mhm.
Regarding offline participant, we'll give it to us.
Good afternoon, sir.
Yeah. Good afternoon.
Sir, all the features which you were speaking were all regarding the chemicals which are present in our body, right? The whole theory was like all the factors like lipid profile or blood count, whatever the chemical was indirectly causing depression if it is low or high. From my opinion, what I feel is it can be vice versa model also. If a person is having depression, it can indirectly they can increase or decrease all the chemicals in our body. Like no psychological factor is like attended in the model which you were speaking. Like if a person is an introvert, there is high chances that he may get depression, because
Mhm.
depression is something which is caused mentally rather than a physical pain. Physical thing is like getting a disease, going to a doctor, getting it cured. But depression is something, so many psychological factors are around it. So I think different questionnaire can be added in the model to train the model.
Yeah, actually, the thing is right. Generally, we feel like depression is all about mental issue. I mean that it's not about physical things. Actually, it is the physical things and chemical composition and their mental health. All these three things are combination for the model. Because if you are not if you're not I mean if you're not what do you say, if you're not mingling with the people physically, then like you will feel alone. That may create one issue. And second one is like the chemical composition what you written, right? You can see that even you can google it, or wherever you found, just see the things. That is albumin and iron, these kind of chemical is there, right? So it will affect on the brain in kind of thinking, how they need to think. And if the albumin is very less, then definitely it will affect on their mental health. So like we need to think all the kind of what you will say, uh, all kind of, we need to think in all all the way where we can where actually the probability of depression can occur. For example, chemical composition, physical activity, and how they are mingling with the people, what actually they are thinking, what may be the reason. Like you need to think in this way. Still it is a research topic. You can say like sometimes in one my research work, the people one who are having obese, they said I am going to gym. Okay, but the final report what I got, the people one who are having obese, they are going gym. I mean the people one who are going gym, they are obese, right? Sometimes the research may give that answer where it is not justified because of the thing that is you can say that anomalies. So that's why we need to have lot of data to process the things. I'm still working on this one. So like I will take input from you, like that what you are told. But generally we can say that all the things are matters when we are dealing with the depression one. Yeah.
Yes, sir, exactly as you said, there are several causes of depression. Like we cannot predict from only the body chemicals which we have,
Hmm.
and indirectly those factors will be affecting our mental health. And these days, like people are feeling very free to go to a psychiatrist and have some counseling session. They do not go to a physician, and the counselor, he gives just a medicine of nerves, and the those medicines are helping only to decrease the sad hormones. It is
Yes.
just a hormonal tablet. But we do express everything to a counselor, which we do not do with our like relatives or friends, or even uh, our partner, maybe. But
Yes.
we do agree with the counselor who is a stranger, because he will not judge us. We will feel free everything that what we feel. We will express everything. So by that counseling session itself, halfway we will be get done.
Yes, yes, you are right. That is true actually, because the primary counselor, like if you are facing any issue, the primary counselor will be your, partner or your parents or your friends. So if you had a better discussion with them, then they can understand you in a better way. They can give you a possible solution. If not, you can't, say these things. Then you can go with have a discussion with psychiatrist or a doctor. But generally, I will suggest. I had a discussion with the people, and your routine will matters a lot. I can say directly, because when even I can say that when I'm I will not generally I used to not do workout, but from past 1.5 2 months I started workout on all these things. The thinking, the way of energy what I have, that is different from the casual uh, day what I had earlier.
Okay, sir. Thank you.
Yeah, welcome.
Thank you very much, sir, for sharing all your information.
You're welcome.
Yeah. So now we'll have a 10 minutes break. The next session will start at 11:25 sharp. I request all the participants to stay in the Google Meet.
Okay. Thank you all. Yeah. Bye.
Thank you.
Yeah, you're audible, sir.
Welcome, sir. We'll be starting the session at 11:30 sharp. I request everyone to stay in the Google Meet. A very good morning to everyone present here. I'm Basha from 6th semester CSE department, and it's my pleasure to welcome you all to the 8th session of day 3 of the 3-day faculty development program conducted at New Horizon College of Engineering. The topic for the current session is AI in medicine, mathematical aspects and implementation perspective. This session is taken by Dr. Raja C., Associate Professor, Department of Electronics and Communication Engineering, Welltech Rangaranjan, Dr. Shakuntala R&D Institute of Science and Technology, Chennai. 17 years of teaching experience and 6 years post PhD as an associate professor. He has coordinated formulated syllabus and conducted skilling course for DSP in KLU, presented guest lecture sessions in Puducherry Technological University and other organizations in 2021 and 2022 in the topics AI in medicine, implementation perspectives using Keras and TensorFlow, and writing research article in research pedagogy. Handled administrative roles like institution level research council coordinator in SSCE and MVJCE, department level IIPC coordinator in MVJCE Bangalore, and as an examination representative for AU exams. He has also participated in BOS meeting for medical electronics in VTU Bangalore as a special invitee. He has also presented to Karnataka State Council for Science and Technology, seeking for a fund of rupees 5 lakhs for the proposal automation in TB diagnosis by improved AI methods, based on the initial scrutiny as principal investigator in the last semester. Sir, it's a real honor to have you here, and I request you to take the session.
Yeah, thank you, Mr. Raja. Hope I am audible. Am I audible? Hello.
Yes, sir, you're audible.
Yeah. Thank you, Mr. Raja. I will go right away to my presentation. Yeah, now I thank the entire management of New Horizon College of Engineering for providing me an opportunity to conduct my session on artificial intelligence and machine learning for healthcare engineering. And I have been seeing the brochure for the last the program that has been happening for the last couple of days.
Excuse me, sir. Your
I
voice
thank.
is not
Yeah,
clear. Can you
is
please
it clear
speak a
now?
little louder?
Yeah, okay. I thank the chief patron, Dr. Mohan, and the patrons, Dr. Manjumata, the principal, and Dr. Sanjeev Sharma, the dean, and the Dr. Anandi. And I especially thank the coordinator, Dr. Santosh Kumar, who has been my friend, and also the convener, Dr. V. Rajalakshmi. And once again, thank him, the New Horizon College of Engineering, for providing me this opportunity. And I hope that you have enjoyed and had a useful interactive session in the last couple of days. Coming to my session, we are going to discuss on implementation perspectives in the afternoon, and in the morning we'll see the basics of artificial intelligence. That is, in the morning session we are going to see uh, this AI in medicine, mathematical aspects and the implementation perspectives we are going to see in the morning. And in the afternoon session we'll go for the hands-on using Google Colab optics and subsegment, the experimentation of optical disc and the subset. So based on the timing, we can extend or we can compress the sessions with the inclusion and exclusion of topics. So that is dependent on the interest of the audience. So I would have my session in this way. That is mathematical aspects in a simple BPM. So somebody may be having a very fresh hand. They may be an expert in another field, but they are putting their hands. They may be putting their hands freshly in artificial intelligence. So to cover the needs of everyone. So most of you may be knowing what is the mathematical aspect of a simple backbone propagation network. If you take a textbook like Zaruda, you're going to anybody can learn all these things. And now in the undergraduate curriculum itself, we are covering all these things. Anyhow, to have a completeness, we'll have the background, mathematical aspects in a simple BPM. And yesterday, I have been discussing with Dr. Santosh Kumar also regarding what are the topics that were delivered by the experts in the last 2 day sessions, and I got an insight that anyhow, whatever I am teaching will be in a different perspective, connecting with whatever implementation we are going to do, connecting with that the basic mathematics you will see in the morning. Okay. So anybody is free to interact. If at any point of time you feel that my presentation is being a little bit of more theory and mathematical aspect, let us keep and have a more insight into the implementation aspects. I welcome the audience also to interrupt and talk, and they may ask me to skip the sessions if they are feeling that I'm covering mostly on known topics. They may skip me or they may intimate me also. So I don't have any objection in skipping up the topics. And then mathematical aspects of data, linear, what is meant by linearly separable and linearly not separable data, and introduction to deep learning. What are the mathematical aspects of convolution layer? So when you go for deep learning, you use the convolution layer for feature extraction. And mathematical aspects of activation function. We will see what is the main activation function also for machine learning and deep learning. And what is the vanishing gradient problem and how it affects deep learning algorithms specifically, not with respect to machine learning algorithms. And what are the popular CNN models? So this I would call totally theoretical and mathematical. And after that, we will come to the implementation perspectives. What are the different? Anyway, I have not included in the slides. What are the different tools available to implement all these deep learning algorithms and how they can be implemented? Right from installation, also I will give you some insight. I think already the installation details have been shared to you by the organizers regarding how to install the Python. So if someone wants to really participate and really do a hands-on session when I am doing the exercise, they can also come along, and that can also be done in the afternoon session. So basically, I'm going to have three exercises, three programs, time permits. Otherwise, we will end up with two programs. One basic MNIST classification of MNIST dataset. What is the MNIST dataset? We will see. It is a very basic image processing dataset. It's a very simple image processing dataset that we will see. And one more thing, optical disk and touch segmentation. It's a real-time application with real-time images downloaded from datasets. And then if time permits, we'll also see how to do the workup with the tabular datasets. With Excel sheets and all, we have lots of data. How to work with the deep learning architecture, taking those Excel inputs, that also we'll see from time permits. So in the morning session, we'll be seeing this mathematical perspective. Anyway, without mathematics, we cannot directly jump into the implementation aspects also. So what is the AI, machine learning and deep learning? We have seen already in the last 2 days session. AI is a whole area where computer mimics the human intelligence, starting from the simplest use to the entire deep learning. AI is an entire set. Whereas when you come to machine learning, it involves more of core engineering. So right now, machine learning is there or not is a very complicated question. So whatever we do in deep learning, that also falls under machine learning. So a machine learning algorithm involves the core engineering, more of core engineering for feature extraction. What is the more of core engineering in the sense? Suppose we are dealing with medical images. What are the details of medical anatomies? The size of the optical disc and size of the optical cup. So all those core engineering level data sets are being extracted. So those are being segmented and those features are being taken and they are fed to artificial neural networks. That was the era of machine learning. Now coming to deep learning doesn't much bother about the domain specific features. So here you have some set of filters for feature extraction and finally fully connected layers for classification. So deep learning doesn't that much bother about the domain specific features. Here we are not going to extract the, for example, if you're taking medical images, we are not going to segment the optical distance performance. So everything can be put in the same framework where the deep learning algorithm will be having thousands, hundreds of layers feature extraction and hundreds of layers for classification. So going very deep, that's what is deep learning. There is no much botheration on the domain specific features. So this is an absurd statement based on the implementation, based on knowledge, whatever I have here, based on the practical experience I am talking. Maybe sometimes different also. Okay, theoretical aspects may be little different. Whereas coming to the implementation perspectives, when we work with artificial neural, we can also see in the other terms. Machine learning is the mostly implementing the artificial neural networks. Whereas deep learning, we mostly implement the convolutional neural networks. So when we are using artificial neural networks, we get the domain specific features. We are dealing with the satellite images. Those domain specific features will be extracted. we are using medical images, those domain-specific features will be extracted. But coming to deep learning, it is entirely different. There are standard convolutional neural networks which have standard set of layers, like AlexNet or ResNet. All those networks will be having their standard set of layers, which are eligible to work on any type of images. That's what, based on my experience, I'm putting it simply. And AI in medicine, mathematical aspects and implementation perspectives. Coming to afternoon's session, is gold standard medical and other data sets. What are the data sets that are available? Just a minute. Hello. Hello. Yeah, am I audible now?
Yes, sir. You are clear, sir. Now it's audible, sir.
Yeah, please stop me. The main session itself, you can stop me. No worries. Yeah, okay. I was telling about today's session, today's morning session, and afternoon session. What we are going to see, that is mathematical aspects of simple BPM we are going to see, and what is by linearly separable data we are going to see, and what was the difference between deep learning and machine learning I was talking. Machine learning is more concerned about domain-specific features I was telling. So, whereas deep learning is more concerned, not much concerned about the domain-specific features. Domain-specific features in the sense we are dealing with medical images, particularly eye images. We are dealing with the size of the optical disc. We want to identify some disease. We want to diagnose some disease. Then the size of the optical disc and size of the optical cup matters a lot. So such features are extracted in the machine learning era. So we were using artificial neural networks. So when we come for deep learning, we take up convolutional neural networks. We can take that similarity also. When it is machine learning, we use artificial neural networks. When we go for deep learning, we take convolutional neural networks where domain-specific features are not that much bothered. What we do now, we depute the same CNN to different types of images. The same CNN may be working with satellite images. The same CNN may be used for medical images also. That is, networks like AlexNet, ResNet, and all are being used. So we can see the papers published with these type of neural networks with taking inputs of different images. The images belonging to different domains. That's what. So So machine learning was much domain specific. The features extracted were much domain specific, and we use ANNs. Whereas here we go for convolutional neural networks. That is what the thing I was talking about. The basics of the artificial intelligence applied to medical imaging or medical data processing, we will be seeing in the morning. Mathematical aspects we'll be seeing in the morning. Whereas in the afternoon, we'll go for the real implementation perspective. That is, what are the different gold standard data sets available? So data sets are very important. So when we talk to some undergraduate students, when they want to do a project in image processing, they will keep on saying that they will acquire their own images for their project. It is not possible. We almost have data sets for all types of domains, all domains we have. So what are the different data sets available for implementing the code, and what are the implementation perspectives? How to implement it? So MATLAB is little outdated, so we are going to find Python. So much free coding is available only with Python. If the cutting edge CNN and deep learning we are going to implement now, whether to do it in MATLAB or Python is a big question. So what we can do now, we can go for MATLAB also. But why I recommend Python is you have to learn a new language. Why? Because so much of free coding is available in GitHub in Python only, and whatever recent papers are being published with impact factor more than 3 and all, they sometimes give the codes for free in Python only. So you can download the Git and you can keep working on that particular existing model and rephrase the model, and you can appear your degree by just modifying some of the codes, subjectively justifying what you have modified and how that subjectively works for particular how that subjectively works for your particular application. That's what we are going to see. Implementation perspective we are going to see in the afternoon. So what is Python libraries we are going to see in the afternoon. Why we are going to use Google Colab. Google Colab is an environment where we can run the Python codes. Okay. So what is the difference in running the Python without Google Colab and with Google Colab that you will see? To handle thousands of images and even millions of images, Google Colab provides a free cloud space. So that's what the importance of having a user in Google Colab. If you have a Gmail account, you can generate your own Google Colab account also. So which will be providing you cloud service. You can run your Python course. They also in two ways. That is, you can, for computation also the space is given by the Google, and whereas for storage also the space is given by the Google. And implementation of CNN for MNIST dataset. So most of you familiar with the MNIST dataset. It is a handwritten character dataset. So it is why it is always used for the first experiment in deep learning. Everyone will do is using MNIST datasets. Why in the case? Because that is the most simplest thing. That is the simplest thing, and it is called as a hello world of machine learning problem. That means any algorithm is first tested on MNIST. If it is not going to work on MNIST, it is not going to work anywhere else. And coming to real-time data sets like optical disk segmentation, optical disk and curve segmentation, that also we will see. So the coding part I have already shared for this MNIST dataset, and how to implement Python and how to get a user in Google Colab. That particular documentation I shared yesterday, and the code for MNIST dataset I have already shared. So when you want to work in hands-on, you can do this MNIST dataset classification. You can do in the hands-on. Now coming back to our lecture, it is a continuation of this. Anyway, the slides are a little bit realigned, it seems. So after this artificial intelligence, machine learning, and deep learning, we come to further understanding about what is the difference between machine learning and deep learning. Okay. So you see, in machine learning, there is handcrafted features. That is, this feature only I want to extract. For example, if it is a medical image, I want to segment the optical disc, size of the optical disc, and size of the optical cup is one of the significant feature in the medical image or classification of a disease. Or if you are working with brain images, then with the cerebellum, area of cerebellum, all our things are very, very important. So more handcrafted features are taking in the machine learning era. Whereas coming to deep learning era, you see the simplest features, more complex features, mapping from features. So this is nothing but the fully connected layer. So the engineering goes like this. Here there is no much domain-specific features. Any image can be given to a very popular neural network like ResNet or AlexNet. Those are all deep learning architectures. People keep on publishing by changing the architecture a little bit, by adding more and more layers, or by changing some of the activation functions or changing the loss functions. That can come into that can result as a good publication for your research. So what is an artificial neural network? Starting from the beginning, An artificial neural network is a biologically inspired AI model. So it is a biologically inspired AI model. It is inspired from the humans, in which during the training phase the weights are learned, and during the testing phase the weight learned are used to classify the data. So it resembles a human brain. So it is a biologically inspired network. So what we are going to do now, the weights are learned during the training phase. Suppose you want to buy a new mobile phone. So what are all the parameters you will see? 6 GB RAM, 12 GB internal memory, this much megapixel camera, and some more features. So totally 4 features you are taking into account, and you are having two outputs. That the outputs may be taken as less than 20,000 and greater than 20,000. You give the input of several hundreds of phone models. So this much megapixel camera, this much internal memory, this much RAM. Likewise, you give the data and say that this phone's cost is 15,000. Then it will be taken as less than 20,000. Another class being greater than 20,000. Likewise, if you feed with so much of input data, when you have a new model, when you have a new mobile model, when you give that particular input, this much this thing, this much the internal memory, all those inputs if you give, the weights that are already learned, the weights that are already learned will be used to identify whether the cost of the phone is eligible to be less than 20,000 or greater than 20,000. That's what is the simplest artificial neural networks. So weights are learned in the sense we can have a simple example. Suppose two persons are there, they're telling something. So you give the ultimate weightage to the first person. The ultimate weightage is given to the first person, and the nil weightage is given to the second person. So that what happens? So that what happens is, suppose there is a failure. If there is a failure, then what we can decide now? You can reduce the weightage for person one, and you can increase the weightage for person two. That is reducing the weightage for person one from when you reduced it to 0.7, and increase the weightage for person two means you increase from 0 to some 0.2 or 0.3. It's a very random thing I'm saying, but there are different algorithms for weight change also. Gradient descent algorithms are there for identifying the weight change. That is what is the working of artificial neural network. So several layers are there. So everything works on modification of the weights. So it is a biologically inspired artificial intelligence model. And more importantly, what is the linearly separable data we need to understand. So we need to depute the machine learning and deep learning algorithms only to linearly non-separable data. So we'll see what is be linearly separable and what is be linearly non-separable. So when you look at this particular picture, there are green dots and red dots. You can comfortably draw a line segregating the green dots and the red dots. This is said to be linear separable. So when you look at the what the machine learning algorithm learns, it learns the slope of the line. Y is equal to mx plus c. That is the equation for a straight line. The straight line is able to classify between two classes. Okay. So in machine learning perspective, you see the same equation becomes y is equal to weights multiplied with the inputs plus bias. So in machine learning terms, this will become weights into inputs plus bias. And that's what here m represents the slope of the line and c is the bias. That is the location of the line. So m represents the slope. Likewise, c represents the location of the line. Whether this line has to be upwards or downwards, that is given by the value of the c. Where w is the weights and b is the bias when you come for the machine learning perspective. That's what an artificial neural network does is it learns a line that better classifies between two classes. An illustration of linearly non-separable data. What is by linearly non-separable data? Na? So it was not relevant to the previous one. Now you look at this type of data. This type of data, you cannot draw any line that better classifies between these two classes. So what you have to do, this is said to be a linearly non-separable data. So how this can be segregated and how this can be classified? Take the second example. In the second example, if we imagine that all the blue dots are coming upwards and the yellow dots are staying down itself, then what happens? You can draw a line or a plane that is in between height between the yellow dots and blue dots, and you can segregate between those classes. That is what is making a linearly non-separable data to a separable data. What particular mathematical aspect does this in machine learning algorithms? It is activation function. Activation functions are the important parameters that converts the data from a linearly non-separable space to a separable space. Otherwise, you imagine a balloon. In that balloon, different colored dots are closely together. When when you blow up the balloon, what happens? There is space that segregates between then we are able to segregate between the two classes. That is what is by linearly non-separable. And one important lesson we have to learn in this particular domain is only for linearly non-separable data we can use machine learning or deep learning algorithms. We are not going to use machine learning or deep learning algorithms for linearly separable data. It is not at all required. Okay. Greater than 50% is pass, less than 50% is failure. That is linearly separable data. Similarly, more than this temperature it is fever, less than that temperature it is fever. It is a linearly separable data. For all these type of classification tasks, we are not going to use machine learning or deep learning. We are going to use machine learning or deep learning only for linearly non-separable data. And particularly in a machine learning or deep learning algorithm, which particular thing is going to convert that linearly non-separable item into a linearly separable item? That is called the activation function. Activation function is going to separate it into it goes to a larger dimensional space so that it becomes separable. Different classes become separable. Class 1 and class 2 becomes separable. The activation function in ANN and CNN. So these are all the similarities. When you look at the engineering aspect, machine learning and deep learning are similar. They are similar. So most of the things are in common. Only difference is the machine learning involves more domain-specific feature extraction, whereas deep learning involves only less domain-specific feature extraction. Okay. The activation function in an ANN or CNN and the kernel function in SVM transform the linear space into a non-linear space. Otherwise, we can say it as a linearly non-separable data to a linearly separable data to a higher dimensional space. What is by supervised learning? So I'm just giving an insight, a theoretical insight of what and all are required. So it may be an UG student, maybe a PG student. Freshly, you want to put your hands into the machine learning or deep learning, the most hot topics today. Artificial intelligence based projects you need to know. So sometimes students may be not be knowing all these things, and uh, we need to have an awareness on all these keywords. What is basic supervised learning? Supervised learning in the sense we have the key terms again: X train, Y train, X test, Y test. What are all these terms? So the training data. So that is X train and the Y train. What is the label of the training data? That is a class. We don't know here. Yellow dot and blue dot. Yellow is one class and blue is another class. Similarly here, Y train means what is a class? Suppose I'm having first variable. What is its belonging? Which class it belongs? That is Y train. So some data I use for training, some data I use for testing. That is what is X train, Y train, X test, and Y test. These two are put together training data. These two are put together means this testing data. Okay. X Y means X means the actual data and Y is its class. X1, Y1, X2, Y2 we can say. X1 is the first data, Y1 is the class of the first data. So likewise, how do you do the machine learning classification task? To understand, I have made a simple table. Suppose you are working with the images, 82 images you have taken. Ultimately, you will be using 80% of the images or somewhat for training and remaining images for testing. So I can ultimately say this is a training data and this is a testing data. Okay. So the training data. So the training data is not given as such. Features are being extracted. Feature 1, feature 2. So I told now here in machine learning era, what is done now? Domain specific features are extracted. Handcrafted features are being extracted. So those features are nothing but this. The features are extracted and these are called as X train. X train means training data and X means the actual data. Okay. What is Y train? Y train is the class of the training data. The first image belongs to normal image. The last image belongs to abnormal image. That is given by class 0, class 1. Okay. So two class classification. It's a two class classification problem. Class 0 means it is a normal one. Class 1 means it is an abnormal one. We usually take the implementation. Okay. And then coming to testing data. So like your training data, from the testing images also the features are being extracted like this. And your algorithm predicts based on the weights learned. That's what I told. When we have a simple artificial neural network like this, you are giving the parameters from different mobile phones. So the weights are being learned. In every iteration, the weights will be modified. Okay, I don't know. You are giving ultimate importance to one person, that is weight you are giving as 1. You are giving least importance to another person. Weight is you are giving as 0. Then your classification fails in the sense you will modify the weights. So that is what is the learning of the weight. Gradient descent algorithms work on modification of weight based on the error. Based on the error, how to modify the weight. That is what is said to be the weight learning. In the weight learning process, that has to be modified. So that's what. So based on the learning, what does that algorithm predicts? That is what is said to be weight test. Sorry, algorithmic prediction. Algorithmic prediction is called as weight predict. Based on the learning, when you give the new set of inputs, what the algorithm predicts, that is what is said to be your weight predictor. And what is weight test? Like we have the class for these data also have we have the classes, and whether class 0 your algorithm predicts, whereas the ground truth is also class 0 means there is no error. Otherwise there is a error. So this is what is said to be a supervised learning task. And what is by feature extraction also will have a little insight. Feature extraction means the image cannot be kept as it is. We need to extract from different. Suppose we want to an algorithm wants to identify any. Let me read it. Any ML or DL algorithm exhibits training and testing phase. The training phase consists of feature extraction. In the training phase, we extract the features. Of course, in the testing phase also we extract the features. Feature extraction and weight learning. What is by feature extraction? Suppose you want to identify whether this is a human face or not. Then the intensities and textures at these particular points may be important for me. So we extract the intensities and textures at these particular points and we feed them to a neural network, whether it is a human face or not. Similarly, a medical image. In the medical image, you want to identify some disease. So this is a normal image. This is a so both are having some disease. This is also having diabetic retinopathy. This is also having diabetic retinopathy. So I think the left image is having more impact of the disease compared to the right. Then what is being done now? So there are some bright spots. These bright spots are only contributing to the disease. So this bright spot I am not bothered. That is the optical cup. So these bright spots should be extracted. This is what is called the feature extraction. Whereas here we have so which is having more disease. The left one is having more disease because after the features are being extracted, we can see directly this is having more disease. Likewise, extracting the intensities and textures from different points that contributes to the feature extraction. And then we have to see the artificial neural network in a nutshell. So how it works. We have seen a non-technical diagram like this, and how that works technically also we need to see. So that is an artificial neural network. I told that several features are being extracted. So these are the features that are given as a input, and this is said to be a hidden layer, and this is said to be a output layer. So any number of hidden layers may be there. So more and more hidden layers you put, you increase the non-linearity. What is the advantage of increasing the non-linearity? The dimensionality of the features get increases so that they become very much separable. So I told the first example, you put dots on the balloon, and when we blow up the balloon, the feature space increases. When the space increases, what happens? It becomes separable. Okay, that's what. When you add more and more layers, you have the linearly, the data becomes highly linearly separable. And this is what the features are being given as an input. This is a hidden layer. The hidden layer is named as are named from Q1, Q2 to QP, whereas the output layers are named from Y1, YK to YM. And how the data learning will be done now. So this is available in the artificial neural networks by Zeruda. So that is a very basic of artificial neural network. That is that book talks about the very basics of artificial neural networks. So if you take that book, it will be very helpful. So net input to the hidden layer. So forward pass. Forward pass in the sense how the data are being learned. And the error calculation and all comes as a back propagation. First the inputs are learned and features are extracted in the forward pass. In the forward pass, what happens we are going to see. In the forward pass, each one has each unit is each hidden layer has several units. In each of the units, how the inputs are being taken, we are going to see. Suppose Q1 to QP. What is done? QIJ. What is the QIJ? So if you see here, this hidden layers are named as J and input layers are named as I. So Qij typically means from the ith input layer to the jth hidden layer. So for that, what we do now, xi is one of the inputs. So this input xi, okay. Then it is a variable x1, x2 up to xn it will be taking. So xi into Vij. What is the input is multiplied with the x1 is multiplied with the V11. That is V11 in the sense first one is corresponding to the input layer and second one is corresponding to the output layer. And this particular line represents x1 multiplied with the V12. Here x1 is multiplied with the V13. So V11, V12 and V13 are the weights corresponding to the this particular lines. Connecting the first input to the first hidden layer, second neuron of the first hidden layer, and the third neuron of the first hidden layer. In such a way, it is being cumulatively summed. So the same input is having different weights for different units of the hidden layer, and they are cumulatively summed, which is added with the bias. Bias is corresponding only to the output layer, Bj. That's the output layer in the sense now hidden layer. Okay, that bias B1. So we have bias B1, B2, B3 for each of the units of the hidden layer. So like I told, what is the significance of the weight? Significance of the weight Vij, and what is the significance of the bias? The significance of the weight is nothing but when you are classifying the data, the weights are learning the slope of the line. How the line will be having the slope is being learned by the weights. And what is a bias? Bias dictates where the line should be, whether it should be upwards or downwards. That is what is given by the bias. In such a way, the net input to the hidden layer is being calculated and output of the hidden layer. This is also very, very important. So, output of the hidden layer will be after this cumulative sum, there is some activation function which acts upon the actual value. It denotes a non-linear activation function. So activation functions are also very, very important, which transforms the data from a linear space to a higher order space. That's what the activation function is being taken. So when I explain the hidden layer, the same is the case with the output layer. Okay, Qj, Wjk. Wjk in the sense W11, W12, and W13, weights corresponding. Similarly, if you take from here W21, W22, and W23, the output will be Q2 likewise. So Q2 into W12, W22, W23. So likewise, the weights are multiplied with the same input. So when you are having three output layers, the weights, there will be three different weights added with the same bias. Like the hidden layer has its own activation function, the output layer will also be having its own activation. And one more important understanding we need to have here is, suppose if it is a two-class classification problem, there will be only two outputs, two units in the output layer. Okay. Suppose if it is the whatever diagram we are seeing here right now is maybe a three-class classification problem. That's why we are having three units at the. Okay, shall we continue like this? I hope you are listening and able to get what I am talking. Shall we keep continuing like this? Can anyone ensure that presentation is going fine? You're fine. Shall we proceed? Don't know whether the speaker has some problem or is responding or not. Someone has responded. Mrs. Archana Devdas. Is it going fine? Are you getting some points, or directly we can go for the implementation aspects, or we can see the mathematical? Okay, fine. Thank you. So I got some feedback that somebody is listening. So that's what the very basics of artificial neural network we have been talking about. And after that, what happens? Take it up in a later point of the. After that, what happens now? That is what is the training phase we have been discussing. In the training phase, the weights are being learned, and whatever the output the algorithm predicts. So suppose you are having a two-class classification problem in the sense, the first output is 0.1, the second output will be 0.9 using probability 0.1 or 0.9. What is the error is being estimated? The error is being back propagated. That is what is called the back propagation of error. So error is being calculated. What is YK? YK is the output of the output layer. That's what I told you. If it is a two-class classification problem, there will be probabilities. If you sum up, it should be equal to 1. It should be equal to 1. That is, the output is having 0.1 and it is 0.1 times supporting class 1, whereas 0.9 times supporting class 2. And that is what is the algorithm's output YK. Whereas TK is the actual output. How is the error estimated? Error is estimated by simply subtracting the actual output minus algorithm's output. There is a difference between weight test and Y predictor. We saw here now what is weight test and Y predictor. Y test is nothing but the actual ground truth, whereas Y predict is nothing but the algorithm's output. And that is being estimated, and the weights are being updated. Weight should be updated. That is what is the actual learning. Weight should change. In life also we keep on changing our perspectives. Likewise, the weight should be changed. And how the weights are being changed now, there is a weight update rule. Learning rate into error. Very simple thing I am telling. Gradient descent algorithm, stochastic gradient descent algorithm. You register for courses in NPTEL with basic deep learning courses and all. You will have a complete session, a 1 week session on this. What are the different optimization algorithms, gradient descent algorithms, starting from gradient descent algorithms to the latest optimization algorithm will be studied. I'm not talking about the optimization algorithm you use for optimizing the other parameters like PSO and those things I'm not talking about. I'm talking about the optimization within the neural network. That's what. So gradient descent algorithm. What is gradient descent algorithm? It is based on changing the weights in a direction that reduces the dou E divided by dou W. What is by del E divided by del W? There is a rate of change of error with respect to weight. So we told no, weights keep on changing. When you keep on changing the weights, what should happen to the error? The error should get reduced. That's what. So gradient descent algorithm works by changing the weights in a direction that reduces the error, or del E divided by del W. And this del E divided by del W is said to be the gradient. This is said to be the gradient, rate of change of error with respect to weight. This is a very important thing. Gradient descent algorithms and other optimization algorithms work in a direction and change the weights in a direction that reduces the gradient, that reduces the error. Okay. So that's what the basics of machine learning we have seen. And now we are going for layers of convolutional neural networks. What is a convolutional neural network? What are the different layers in a convolutional neural network? So this is what is very, very important, because when you go for very cutting edge deep learning tasks and all, what is very important is what are the different layers. This is what is very, very important. So before that, let me summarize what we learned about the artificial neural network. What is an artificial neural network? It is a biologically inspired neural network. So how it works? It works by changing the weights for different inputs. When you go for the technical diagram, in the technical diagram also, we have the different inputs and how the weights are being changed. Initially, how the weights will be taken, if you ask me, the weights are initially taken to be random. It is randomly being initialized. and whatever is the output is being taken. So based on the error, how is that error calculated? Error is nothing but tk minus yk. Yk is the algorithm prediction and tk is the target. We used to say it as target or uh, ground truth data. What is the ground truth label? The ground truth label minus the algorithm prediction that is being taken, and the error is being back propagated. When the error is being back propagated, what is done in the optimization algorithms, gradient descent algorithm, and other optimization algorithm, they change the weight in a direction that reduces the error. Or rightly to say, they change the weight in a direction that reduces the gradient. The gradient in the sense, the rate of change of error with respect to weight. The error should change more with respect to change in the weights. That is what is said to be the gradient descent. In between, we have seen what is by linearly separable data, what is by linearly non-separable data. Linearly separable data in the sense they can be easily classified by a line. This gives an insight of machine learning. Okay, artificial neural networks learn a line that better classifies between two classes. Y is equal to mx plus c, where m is the slope of the line and c is the bias. Bias in the sense whether the line should be at which position, whether it should be at this distance or this distance. That is what is given by the equation for the straight line. The same works with the machine learning also. M is said to be the weight. Weights are learned for different inputs. Here only one input is given, but when you see the actual neural networks, different inputs are taken, x1, x2. For each input, the weights are being learned, connecting to different layers. And C is the bias that is connected to different outputs. And bias dictates where that line should be. And that is what, in machine learning perspective, y is equal to wx plus b. In the equation for straight line, it is y is equal to mx plus c. Whereas in machine learning perspective, it is y is equal to wx plus b. Where w is the weights, and b is the bias. And what is by feature extraction we have seen? If we put a question, where more features are extracted. So in machine learning also and in deep learning also, features are being extracted. Okay, what is the difference in the sense? I told that may not be true always. So whatever I'm telling is, it is based on the inference and it is based on the own experience. Okay, some theoretical textbooks may not give all these insights, or the insight there may be a little different also. But what I'm telling is based on my own experience. When I implemented ANN, when I implemented CNN, what we did, when I implemented ANN, more domain specific features are taken. Oh no, but now it is not like that. Okay, so you feed the same image to the standard convolutional neural networks. So features in the sense here in machine learning, domain specific features were taken, whereas when we come to deep learning, we don't know what these features are. The convolutional layers in the deep learning neural networks are convolutional neural networks. Convolutional layers will extract those features. That is what we will see in the next. This is what is the entire gist I gave about the working of a simple VPN. What is by error? I told error is important. Error is nothing but the algorithm's output minus actual output. What is by gradient descent algorithm also? What is by supervised learning? So I have given the heading as supervised learning, and I told about feature extraction and this. Supervised learning is nothing but we are giving this Y test. That is why it is said to be supervised learning. If you are not giving this Y test, it is not supervised. It is unsupervised. The algorithm itself predicts the output without any inference to the actual belongingness. It produces the output. That is what is said to be the unsupervised learning. The best example is fuzzy clustering. Coming to the layers of a convolutional neural network, why this becomes very important means when you go to any cutting edge deep learning neural networks or any cutting edge CNN, like ResNet 50 is there, AlexNet was there, even now people are publishing with AlexNet. When you look at any of these architectures, what is basically going to be there means a convolutional layer is going to be there, a max pool layer is going to be there, maybe a dropout layer will be there, a fully connected layer will be there, and finally the activation function. So here, most of the architectures they won't show the activation function in the diagram. So anyhow, when there is a convolution layer, it is followed by an activation function. So in mostly diagrams we are not showing the activation function. And what is the convolution layer? we have been talking about feature extraction. The convolution layers in CNN, they will extract the features. Now we come to CNN. What we saw before is a AN. This is artificial neural network, which corresponds to the domain of machine learning. This is convolutional neural network, which corresponds to the domain of deep learning. Okay. So more and more layers are taken here. So here features were extracted. So when we did the machine learning task, individual features are being extracted and given as inputs. Whereas in deep learning, there are different convolution layers. What those convolution layers are going to do, we see. Those convolution layers only do the feature extraction. And there are some fully connected layers. What are those fully connected layers? They are useful for classification. The convolution layers are useful for feature extraction, and the fully connected layers are useful for classification. Now you may come to one conclusion based on all these statements. The fully connected layers resemble an artificial neural network. So whatever artificial neural network we have here, this artificial neural network is nothing but the fully connected layer used in the deep learning or convolutional neural network. What is the name of the network? Means convolutional neural network, and the domain we call it as deep learning. Why it is deep learning? What is the difference between machine learning and deep learning? The question itself is not so valid because both are same, both are similar fields. Okay. In machine learning, we have feature extraction and classification, maybe a little different. In deep learning, also we have the feature extraction and the classification. So the artificial neural networks are kept here as a fully connected. More importantly, the activation function in the last layer will be softmax. Why this softmax activation function we are using that? It is a probability map. What is the probability map? It gives the probability of each class. Like I told now. So suppose if it is a three-class classification problem, the first class is 0.7, the probability of first class is 0.7, second class is 0.2 means ultimately the probability of third class should be equal to 0.1. When you sum everything should be equal to 1. Such a probability map is given by the softmax activation function. So this is what we are coming slightly from artificial neural networks to convolutional neural networks. We are coming from machine learning to deep learning. So we'll see one by one. So as I told in the beginning, any cutting edge deep learning architecture like ResNet 50 is there. Okay, so much advancement has been happening. So in all these architectures, the basic things what we need to know now, what is by convolution layer, what is by match pool layer, what is by dropout is not given there, and what is a fully connected layer. Fully connected layer you already know. Fully connected layer is nothing but a artificial neural network that is being taken at the output for classification. The output end we have for the classification. The fully connected layer will be at the end only. It is not there. It will not be there at the beginning stages. So a typical CNN. The name of this particular CNN is AlexNet. As you can see from the diagram, the AlexNet is not that much deep. Okay, it is having only limited number of layers. Even though we have come to deep learning, AlexNet is not that much deep. So it is one of the initial stage convolutional neural network architecture. We'll see one by one. What is a convolution layer? So a convolution layer, if you look at the diagram, okay, on the diagram, if you look at the equation, you have this xij is the input image, whereas yij is the output tensor we are having. And what is this now? This is nothing but the number of filters. So in this convolution operation, in this convolution layer operation, we are not having a single filter. We are having a bank of filters. So many filters will be there that will be operating on the image. So that is being operating on the image. That is what is given by the equation. And an illustration of convolution. So as I told you, the figure provides an example of a discrete convolution. The light blue grid is called as the input feature map. So the light blue grid, this is the, so what a convolution layer does. So we have it as an equation. So people who have studied convolution in digital signal processing, for those people this will be very, very simple and easy. Otherwise, if you want to know uh, what is the operation or mathematical aspect of a convolution layer you want to know, you can refer the textbook Digital Image Processing by Gonzalez. Then there you can refer to the topic basics of filtering in the spatial domain. This is nothing but filtering in the spatial domain. Okay, what is the filtering in the spatial domain? You can study from basics of filtering in the spatial domain in Deep Gonzalez book. Okay, it is not exactly the convolution layer of CNN, but there is a basics of filtering in the spatial domain. Okay, so where you can understand this equation better. Okay, so xij is the input where this double summation means all the rows and all the columns. It is operated each row by row and column by column. So totally to say it is operated pixel by pixel. And the first inner loop, there are so many filters. So that's what I told. Convolution layer will be, when you draw it as a convolution layer in the diagram, it doesn't mean a single filter. It has some 30 filters. So the minimum number of filters we'll be using is 30 filters. So the standard architectures have the standard specification. So suppose if you look at the AnnexNet, the first convolution layer will be having 30 filters. The second convolution layer will be having 60 filters, for example. Likewise, it has a standard specification. That is what is what we call as the architecture of a CN. 60 filters. Likewise, a bank of filters are being taken. That is what is given by this particular summation. And this D represents the actual output that has been accumulated in the previous filters. That's what. So we will see. So this is a given input image in the sensor. What these convolution filters will do now. This is an example for a simple convolution filter. Figure 1.1 provides an example for a discrete convolution. The light blue grid is said to be the input feature map. Input feature map, in the sense, it may be an image also. It is an image. So this entire thing is an image. A single input feature map is being represented, but it is not common to have. But it is not uncommon to have multiple feature maps stocked one onto the another. That's what. It is not a single image or single feature map. You'll be having multiple feature maps in a convolution layer because learning is so much. Okay. So a single image will be having multiple learnings in multiple frames. That's what. So here we are showcasing for simplicity a single piece of data. So when you keep this particular thing over this, what is being done? Now sum of products is being done. 0 multiplied with the 3, then 1 multiplied with the 3, then 2 multiplied with the next 2. Likewise, sum of product is being done. 3 into 0 plus 3 into 1 plus 2 into 2. Likewise, it is being sum of products is being taken and the first value is 1. So what is very much significant in this means it may be looking like a simple matrix multiplication, but the outcomes are tremendous. This is what is said to be the filtering in the spatial domain. That is very, very important by selecting the proper filters. There are low pass filters and high pass filters also. Okay. So people who have studied DSP, they may have a very much insight about what is this convolution. And people who have studied this digital image processing, they may be having very much insight on what is meant by that filtering in spatial domain. If you don't know both, you are from a different domain. Basically, with the complete computer science background, if you are interested in what is by convolution layer, you can just go through this topic in the digital image processing by Gonzalez. What is the basics of filtering in spatial domain? You can go through this. And what is how this 12 becomes very much significant? They may be asking me, but they are significant by proper use of filters. This is a low pass filter. Likewise, high pass filters are there. High pass filters are very much highlighting the edges. Likewise, when you use a high pass filter and you run that high pass filter through the entire image, edges will be highlighted. Likewise, it is not only in a single point, it is being moved to the next point. And at each point, which should be the center, there the value is being placed. So after filtering, you may see the size of the image gets reduced by sometimes. Okay. There is a separate formula for that. Okay, I will tell in a later point of the session. So after convolution layer, the size of the particular feature maps get reduced. So if it is a 3 by 3 mask, the size gets reduced by 1. Okay. If it is a 5 by 5 mask, the size will be getting reduced by 2. So 1 in the sense I am telling that one row and one column is being eliminated. So the output size will be 3 by 3. So likewise, it is being run. The effects of convolution we are seeing. So when I told like this, the significance of this convolution may not be understood that much. So the effects of convolution on a LiDAR image. So why is LiDAR image and a cameraman image always used for testing algorithms? These are gold standard images. Why you can search in the internet? Why LiDAR image is repeatedly being used? If we take the digital image processing by Gonzalez, in many places the LiDAR image is given and its outputs are taken and its outputs are seen and studied. Similarly, cameraman image is also taken. Why so? Why they are very much gold standard? It's very interesting. So this is high pass filter. Okay, it is going to highlight the horizontal edges. As you can see, this horizontal point is having, this horizontal plane is having positive values. This horizontal is having negative values. So when you run this particular mask, the horizontal edges will be highlighted. That is what is said to be the feature extraction by convolution layers. As I told, no, convolution layer 1, convolution layer 2. I told that each layer will not be having a single filter. Each layer will be having minimum 30 filters or 60 filters or 120 filters. Likewise, it is being done. And when it is an AlexNet, we cannot change the number of filters in first convolution. If the standard architecture is 30, it will operate in that way only. Okay. So likewise, based the convolution layer extracts the features. So I told in the first convolution layer there will be 30 filters now. Each filter will be producing an output like this. So different features are being extracted from a particular. So that's what I told. This particular deep learning is not having much of domain specific data. Like machine learning. In machine learning, we have domain specific data. Whereas in deep learning, we don't have much of domain specific data. We are not interested much. So you cannot corner me by saying that showing one paper where it is CNN is being used and also domain specific features are also used. I'm talking in general. In general, what is done when you come to deep learning, more and more domain specific features are not extracted. So what extract the features here? Na? The convolution layers extracts the features. You want to study about convolution, go for basic DSP. You want to study about the basics of filtering in spatial domain, go for Gonzalez filtering. So these are all I won't say as research in deep learning. These are all nothing but research in signal processing level and image processing level. Similarly, a fundus image, a retinal fundus image is taken, and how the features are extracted by using a particular filter is being shown. So I allow some time for audience to interact. Let me continue quickly. So if anyone wants to interact, they can talk to me. So that's what the effect of convolution in a retinal image. Then coming to what is main activation function, the most important thing we have been doing after the convolution layer, there is no activation function is not usually shown. I told, but what is the impact of that activation function? As I told here before, the activation function takes the data to a highly highly non-linear space. When the data is mixed up like this, it will be a higher dimensional space. So the actual data, if you imagine like a fruit, the activation functions output you can imagine like a juice. Okay, it gives the essence of the data. Mathematically, what are those activation functions? The purpose of the activation function is to add some non-linearity to the data under classification. The activation function also presents the essence of the entire data. That's what I told. You think the entire data as a fruit, the juice or the extract is given by the activation function. So mathematically, what are those activation functions? Mathematically, they are nothing but a simple binary step function or sigmoidal or softmax activation function, tan H activation function, and rectified linear unit activation function. These are all the activation functions that I have been using. And as I already told, and as I keep on telling the difference between machine learning and deep learning, mostly in machine learning, we have been using these activation functions. Whereas coming to deep learning, using ReLU as the activation function. Why you will see? Because these are said to be saturated activation functions. Saturated in the sense, after a particular point, there is no much change. That is what is said to be saturation. These are saturated activation function, whereas ReLU is an unsaturated activation. So coming to deep learning architectures like convolutional neural networks, we are very much interested in unsaturated activation function, particularly ReLU. ReLU has been very successfully implemented first in the AlexNet architecture. So whatever simplest network I have taken to explain the basic deep learning architecture, there is nothing but the AlexNet, where what activation function was used, ReLU was used. Why ReLU was used? Skipping all these activation functions, these activation functions become saturated. Why you will see? These activation functions are mathematically they are saturated activation functions. Why those saturated activation functions are not suitable for deeper layers, we will see. Okay. In machine learning, mostly saturated activation functions like sigmoidal or tan H were used, but in deep learning, unsaturated activation function is used to address something called as vanishing gradient problem. What is by that gradient? In one of the previous slides, I have told dou E divided by dou W. There is nothing but the rate of change of error with respect to weight. Okay. So I also told that the gradient descent algorithms work by changing the weights in a direction that reduces the gradient. Changing the weights in a direction that reduces the gradient or reduces the error. We can say both. That reduces the gradient also we can say, or that they reduces the error also we can say. So dou E divided by dou W. So the gradient should be alive. Dou E divided by dou W should be alive. So what happens in a unsaturated activation function in the sense? Suppose you imagine this as the weight, this is the error, and this is the gradient. This is error and this is weight in the sense. What will happen when there is when the sorry we have to think in reverse. Suppose you imagine this is the weight and this is the error. Then what should happen? When the weight changes, error should get reduced. But what happens here? There is no much change at all. That's what happens. So that is what is said to be a vanishing gradient problem. We'll explain it properly now. So what is a vanishing gradient problem? Weights are updated such that the changing weight will be proportional to dou E divided by dou W. So this is said to be derivative of error or gradient. The weight change will be proportional. I should properly say as weight change. Weight change will be proportional to dou E divided by dou W. So the gradient in a way controls how much the network should learn. So what is the gradient? Rate of change of error with respect to weight. How much error changes with respect to change in weight. That is what is said to be gradient. That only influences the learning of the artificial neural network. When we saw the neural network first, what we told, now, the weights should change and we should identify the error. Based on the error, the weight should be changing. The error is very less now, the weight should be not be much change. Weight should be kept as constant as possible. That's what. The rate of change of error with respect to weight is said to be the gradient. Okay. So this dou E divided dou W, that is nothing but the gradient may become zero for deeper layers if we use saturated activation functions. We use saturated activation functions, the dou E divided by dou W value will become very, very less. Why in the sense, if you see, Z is a weight. So this is one of the units of one unit of artificial neural network being so nothing but X and Y coming from different units in the previous layer. So what is L? L is nothing but a loss function. A loss function is similar to error. Okay. If you take entity by entity, it is said to be a loss function. So what happens here? This is dou L divided by dou Z. And by chain rule, this is said to be chain rule. That is dou L divided by dou Y. That is rate of change of error with respect to the previous weight will be equal to dou L divided by dou Z into dou Z divided by dou Y. So dou Z divided dou Z and dou Y are nothing but these two weights multiplied with rate of change of error with respect to the previous weight. So it becomes accumulative. So suppose for example, if you imagine this value is 0.0001. Okay. So when that lesser value is multiplied with another value, it becomes much lesser value. So by chain rule, what happens? The gradients get very, very faint, and that is said to be vanishing. So when the gradients vanish, what is the meaning? It is not the network is not learning at all. So this is a problem that occurs when we use saturated activation functions like sigmoidal or language. So what happens? This particular region, when the values become high, there is no learning at all. Whereas we go for ReLU, it is an unsaturated activation function, where on the positive side, it is almost linear. The same value is being taken. Whereas on the negative side, it is taken 0. So this is what is supporting deep learning architectures. Whereas in machine learning, this was not a much a bigger problem because there are only few layers were there. So the saturated activation functions were used. But saturated activation functions became a failure because of the deep learning architectures. So for deep learning architectures, we need to go only for unsaturated activation. So first itself in 2010s, when the AlexNet was implemented, in the AlexNet only, in the competition, ImageNet competition, when the AlexNet was implemented and run, initially itself ReLU was used as the activation function here. So conventional, it became a convention after that using ReLU as the activation function when you are going for deeper layers. So when you are going for deeper layers, you cannot use the saturated activation. So when you looked at the AlexNet, first we saw the convolution layer, and I told after every convolution layer there will be an activation function. So we finished on convolution layer and activation function. Then we will see what is the max pool. So max pool is actually for feature reduction. Okay. So to avoid overfitting, what is by overfitting? If one person becomes very much fit for a particular place only, and he becomes unable to survive at any other place, that's what is said to be overfitting. So overfitting should not be there in deep learning. So another problem after vanishing gradient problem, another important problem that is there in deep learning architectures is overfitting. Overfitting in the sense we have training data and testing data. We have training data. This is training data and testing data. Anyway, for a machine learning algorithm, the testing data looks like a new data. It is not learned by the neural network. It is like conducting the internal exams and final exams. Sets the question. I'm not telling anything negative. Same teacher sets the question paper, and the same teacher also evaluates. So the students are getting comfortable, and that is what is said to be overfitting. Overfitting in the sense you get adapted to a particular environment very much. So the person may suffer in another environment. What is another environment? Some new set of images are the sense network which is tested that fails. Okay. For that only we need to go for data reduction, training reduction. The data reduction is done by max pooling. So whatever features we have extracted, we are not going to burden the classifier with all those features. We are going to reduce the features or cut size the features. That is done by the max pooling. So max pooling is very, very simple. Unlike convolution layer and this activation function, so much explanation I need not give. Max pooling is nothing but it is a 2 by 2 max pooling. Maximum value is being taken. produce revenue. You take at the last particular frame, which is the highest value is 5. And 5 is taken as the output. As in a typical CNN, so many convolution filters are used. As I told you, many convolution filters will be used. If it is an AlexNet, for example, the convolution layer, first convolution layer, some 30 filters may be used. The second, so many repetition of convolution layers. The convolution layer, so much filters are being active. So in such a situation, so much of data is there. So to avoid redundancy, in every stride, what is done in only the highest value is being retained. This is what is said to be max pooling. Hence, too many features burden the CMM. So max pooling is done to reduce the redundant features. And what is a fully connected layer? I told finally after the scene. After the convolution max pooling, finally you have the fully connected layer. I told the fully connected layer resembles the artificial neural network. You can think of this convolution layers for feature extraction, the fully connected layers for finally you have softmax activation function. What is the significance of the softmax activation function? It produces probability maps. Suppose if it is a two-class classification problem, it produces the output as 0.8 and 0.2. So the probability of first class is being 0.8, and the probability for second class being 0.2. So whenever we cannot use reduce the activation in the last layer, the activation function that should be used in the last fully connected layer. Even in this fully connected layer, we have the liberty to use any other activation function. It is the final thing, we have to use only softmax as the activation. So why I came back to this slide is these convolution layers do the feature extraction, and the fully connected layer does the classification. And that's what is being told here. The fully connected layer resembles the artificial neural network, where the weight change or learning will be complete. So it looks like a fully connected. That's what we have been mainly talking about. What is by an ANN? We saw what is by back propagation. We saw what is by forward pass. In forward pass, how the weights are being learned. The basic thing we saw about machine learning. And after that, we saw what is by supervised learning, what is by feature extraction. We saw what is the difference between machine learning and deep learning. Okay. How the domain specific features are much extracted in machine learning, and how the convolution layers extract features from different domains of images in same way. That is given in the deep learning. And what is my convolution layer I told. What is my max pooling I told. In between, many other important things also I told. What is my activation function I told. In machine learning era, what are the activation functions used I told. Tan H or sigmoidal, those activation functions were saturated. Saturated in the sense there is no change in the output, when the input also changes, when the input changes, there is what is the saturated activation function. The saturated activation functions failed in the deep learning. Why? Because of the vanishing gradient problem. Gradient is a key term. What is by gradient? Dou E divided by dou W. That is rate of change of error with respect to weights. So what is the ultimate use of changing the weights? When you change the weights during learning, because of changing the weights, the error should get reduced. That is what is said to be learning. Dou E divided by dou W. The gradient should be alive. When the gradient is alive, only the learning happens. But because of the saturated activation function, the gradients become vanished. That is what is said to be vanishing gradient problem. So when you go for deeper layers, this particular problem occurs. So for that, we came with the AlexNet, the author of AlexNet, the person who found the AlexNet in the ImageNet competition was first recruited in 2010. When the AlexNet was implemented, ReLU was first used as the activation function for deep learning. After that, it became a convention. Whenever you are going for a deep learning architecture, taking more and more layers, why it is said to be deep? It is said to be deep because we are using so many convolution layers. When you look at the AlexNet itself, you can see AlexNet is a very simple deep learning architecture. So if you take ResNet 50, it is much bigger only. It is several times bigger. So in AlexNet itself, several convolution layers are there. In each convolution layer, banks of filters are there. So much feature extraction is being done. That's why it is said to be a deep neural network architecture, or the domain is said to be deep learning. Okay. After that, we saw what is an activation function. And after that, what is a fully connected layer also we saw. Fully connected layer resembles the what? A simple artificial neural networks. This is where the actual weight change will happen. The weight changes are not happening in the convolution layer or these are typical feature extraction phases. Convolution layer, max pool layer, dropout, all are feature extraction. Whereas fully connected layer only corresponds to classification. The actual weight changing and actual learning happens here. So in afternoon session, you will be seeing much more interesting. What are popular CNN architectures? AlexNet you will see. And after that, how a bigger AlexNet looks like, and what are the different data sets available to do. So afternoon sessions will be much with the implementation perspective. First, what are the different data sets available to scratch up your machine learning task, and yeah, different data sets, standard data sets and very domain specific data sets you will see. And after that, some tabular data set also you will see. What is a tabular data set? And what are the different Python libraries you will see, and how to do the installation. So exact elaborate installation procedure is not given here. What are the different ways to work? What needs to be installed for what is being discussed? It will be discussed in here. And once a particular example, hands-on session will be used for classification of MNIST data set. MNIST is nothing but handwritten character recognition. So this is your MNIST. How data classification is done using MNIST. That you will see in the afternoon. And after MNIST, segmentation. Segmentation algorithm will be done. What is the segmentation? Segmenting the optical disc. That code will also be explained. Based on the audience interest, whether we can take the segmentation or we will do a task with the tabular data set. Okay. So already, so we will decide in the afternoon. We can do segmentation, which is elaborately image processing only. Whereas if we want to learn some example for tabular data set classification, we can do that skipping segmentation also. Okay. So that input I need from the audience. Thank you all.
Thank you, sir. It was really a good
Meet up in the
presentation,
afternoon.
sir. Participants, do you have any queries in this session? Sir will be continuing in the afternoon also.
What is the time?
Participants, do you have any queries in this session? Well, if there's no questions, we'll have a formal conclusion, sir.
Thank you very much, sir, for the informative
Meet the
session.
afternoon.
Now we'll have lunch break till 2 o'clock. I request all the participants to be back in the meeting by 2 o'clock. Raja sir will continue his session at 2 o'clock. Thank you.
Hello, Raja sir. Is it audible, sir?
Yeah, am I audible, sir? Santosh, sir?
Yes, sir. It's audible, sir. Just a minute, sir.
Am I audible? Yeah, fine.
A very good morning to everyone present here. I'm Basha, again hosting for the last session of the FDP program, session 9 of day 3. And the topic for this session is a hands on session on Google Colab optical disk segmentation with Drishti database. And our speaker for this session is Dr. Raja C. again. Sir, please share your knowledge one more time.
Yeah, thank you, Mr. Basha. We'll start the session right now. I think you have to give me the presenting option.
So there is some disturbance on your end, sir. Just check one, sir.
Yeah, actually, uh, I need to present. Yeah, fine. Is my voice clear?
There is some sort of like disturbance in the background noise, sir.
Is it clear now?
Yes, sir. It's now clear, sir. You can proceed, sir. Fine.
Fine. Yeah, now coming to popular CNN models, whatever we saw in the morning, that is AlexNet, it won the ImageNet competition in 2012. It consists of 5 convolution layers and max pooling layers, and it uses regular activation function. All we saw in the morning. Straight off two in the sense when it is when the filter is moved from one location to next location, it is moved 2 pixels. There is overlapping 1 pixel from one location to next. So when the size of the image, the size of the filter is 3 by 3, when it is moved 2 times, so there will be one overlap. So striding is very important to maintain the uh, record size. So there we use the striding. So two convolution layers, and finally with the softmax activation function is there. That on that we discussed in the morning. And why necessarily the last layer should have softmax as the activation function also I discussed. So which provides probability maps in the range of 0 and 0 to 1. So probability of heads and tails is 0.5 and 0.5. When you sum it up, it is equal to 1. Likewise, any two-class classification problem also means the first output is 0.8, probability is 0.8, and the next probability, the next class's probability should be 0.2. So that's why we use softmax as the activation function in the last layer. So whatever CNN we saw in the morning, that is your AlexNet, as is it. Since AlexNet, the state-of-the-art CNN architecture is going deeper and deeper. So after AlexNet, the CNN architectures are going deeper and deeper. Like we have VGG networks and Google Net with 19 and 22 layers respectively. So VGG also has its own versions. So VGG later versions are also there, which has more layers, and Google Net has 22 layers. So what's the problem in increasing the network depth? So already we discussed in the morning vanishing gradient problem. During the back propagation of error, each layer has a gradient, which becomes negligible when the number of layers increases. So that's why we take ReLU as the activation function. And after that, so one more solution for the vanishing gradient problem is ResNet, that is residual network. So it is also a very deep neural network. It has a 34-layer ResNet. It has a 34-layer network which has skip connections. So skip connections are very important. As I told you in the morning, in all these CNNs, the network may be much deeper and sometimes maybe narrower network may be taken. So what are all the essential layers we have seen in the morning itself? So convolution layers. So 3 by 3 convolution. What is the meaning of 3 by 3 convolution? So 3 by 3 convolution means that when you are doing that convolution operation, the filter you are using is of size 3 by 3. That's what. So you are using here, you are using a 3 by 3 filter. That is what is specified here as 7 by 7. So this is a typical architecture. So 34 layer residual ResNet in the sense, this is the architecture we cannot change. So here I cannot put a 3 by 3 convolution layer. Based on some trial and error and some intuitive engineering, so these networks are being built. What is the advantage of this ResNet over the AlexNet and the GoogleNet in the sense? It has skip connections. Skip connections in the sense the previous layers tensors are taken directly also after putting convolution. The convolved outputs are taken and unconvolved outputs also are taken here. So the advantage of these skip connections being the network being very much deeper and the ReLU activation function offers some solution to the vanishing gradient problem. And this is also another solution to the vanishing gradient problem. These bypasses, not bypasses, we call it as skip connections technically in the deep learning. These skip connections, they maintain the tensors without making the gradient to be zero. The gradient becomes zero. Hello. Yeah. So we discussed a lot about the vanishing gradient problem. So that's what the skip connections help to avoid the vanishing gradient problem. And after, so I want to tell more about the vanishing gradient problems, but we can take it somewhere. You can take it mathematically by referring to textbooks. More interesting topics are up to come. That is data set. So when you are doing a machine learning problem, the machine learning alone is not a field. It has to be combined with either with the signal processing or image processing. As far as I know, as per the domains which I have worked, we have to take it along with image processing. We have to take it along with the data science. So data science has to be clubbed with this artificial intelligence. That's where it becomes meaningful. So when I take it along with image processing, so what are all the standard data sets? So don't entertain the activity of creating your own data sets. So at a very later stage, at the very mature stage of your research, in collaboration with the doctors, we may create our own data sets and we may make it public also. So that will give a very effective return of more citations and all. But initially to start with, we have to work with gold standard data sets. Why these are called as gold standard data sets? Because they are repetitively they are being referred in papers. Some many people do their work with by using these data sets and they publish. So when we do our work also and when we use those data sets also, it is easy to compare and it is meaningful to compare. My algorithm has given this much output with MNIST data set, whereas the other algorithm which is primitive to this where from where I have improved the algorithm. There also they have also tested with MNIST and they produced this much result. So let us see what is this MNIST. MNIST is very basic. And again, I tell you one more point: if you are going to join some course by paying a huge lump sum of money, around more money you are putting it, and you are joining something somewhere in Coursera or Udemy. If the last exercise is MNIST, you cannot. It is not useful to attend that workshop. Why? Because MNIST is a very basic thing. Okay, so as I told, it is a hello world of machine learning problem. What is meant by that hello world of machine learning problem? It is a starting point. Okay, so any algorithm works with MNIST only, then the algorithm becomes eligible. Otherwise, on the other hand, if you want to learn, if you want to learn actually the machine learning algorithms, you want to work with real-time data sets. So first, let us see what is that hello world of machine learning algorithms that MNIST. It is handwritten characters for supervised learning. 70,000 black and white images are there of size 28 by 28. Each image is of size 28 by 28 and 10 classes are there. It is given wrongly. 10 classes are there. 0 to 9, 10 classes are there. It is primarily used to experiment with the different machine learning algorithms and to compare their relative strengths. So it is ultimately when you are attending a workshop on machine learning or deep learning, after learning the very basic network, the first thing you can go for test is with your MNIST dataset. MNIST is often the first dataset researchers try, and ML researchers say that if it doesn't work on MNIST, it won't work at all. So this is a very basic data set which you need to test with to test your algorithm. And after that, you have Fashion MNIST. Fashion MNIST is given in Kaggle repository. Kaggle is a repository where you have multiple data sets. Okay, so many different data belonging to different domains are available in Kaggle. So in Kaggle, one more data set is available, that is Fashion MNIST. So male and female clothings and footwears So 10 classes. This also consists of 10 classes, each of size 28 by 28, consisting of 60,000 examples. That is 60,000 examples, 60,000 images for training, and 10,000 images for testing. So this can be used as little bit as a replacement for the original MNIST dataset for benchmarking machine learning algorithms. So the next level, you have tested your algorithm in MNIST, and you have made some improvement. So next, apart from MNIST, you want to test it to the next level, means you can go for fashion MNIST. The advantage of this MNIST and fashion MNIST dataset is you need not download it to your laptop or computer. You can have it. We can work it within cloud itself. That is the advantage of MNIST and fashion MNIST. I will show you the difficulty, or I will show you the elaborate tasking involved when you want to download some data set, 60,000, 70,000 images we have worked. Like for classifying diabetic retinopathy, we have taken some 70,000 images. When you go for 70,000, when you go for 70,000 real-time images, downloading that and keeping it in a drive and calling it from one location and telling the label, which image corresponds to which class, are all very, very elaborate. So which is not there in the MNIST and fashion MNIST. When you take the data set, automatically the labels are assigned. You will see the example also. Automatically the labels are assigned. Only the network you need to test. So calling the data is the biggest accomplishment for when you do the Python coding. So which is being ruled off when you work with the MNIST and fashion MNIST data set. And next, coming to, I told real-time images. So Kaggle repository gives another diabetic retinopathy image dataset. 35,126 color fundus images are there. We have done one experiment with using this diabetic retinopathy images. So the thing being, in 2015 and 16, when I did my PhD and all, I would have installed a laptop. I would have installed MATLAB in my laptop. And when I want to work with images, I will be working with 100 images. If I want to improve my testing and to take for 150 images, for going from 100 images to 150 images itself, those days were a big challenge. It was a big challenge. So nowadays we are simply sitting. Why? Because of the Google Colab. Google Colab offers the cloud space where the images can also be saved. The images can also be saved in the cloud, and computations can also be done through the cloud. So imagine the computation that is required to be done to deal with 35,000 plus images. In olden days, that's what into before 5 years when I was doing my PhD and all. So when you work with the 100 images, I want to increase the robustness. I want to produce some better results. So if I take some 20 more images, from 100 images to 120 images, if I take it in the sense, it will take another half an hour extra. Already the algorithm would run for 2 hours. So if I increase the number of images, it will go for another extra additional half an hour. So thinking of that, this is a huge leap coming to 35,000 images and all, and testing the deep learning architectures. And particularly this deep learning and big data, all these demand lump sum of data. You cannot design a deep neural network and test with 100 images. Sometimes data becomes scarce. Data is in very scarce, particularly in medical field. For that only generative adversarial networks and all have come. They will generate synthetic data. When you give the original data, based on the original data, if you have 100 images itself, you to sit along with a doctor and to generate some hundreds of images will be a big challenge. And to segregate as the two, several problems are there. Classification problems are there. Segmentation problems are there. To generate the data set for classification problem like this is not having diabetic retinopathy. Diabetic retinopathy stage 1, stage 2, stage 3, and stage 4. So totally, if you count 35,126 images are there, different numbers of images are there. It is a very unbalanced data set. So this is what we call as an unbalanced data set. It is not 35,126 divided by 5. Okay. Somewhere it is 700, somewhere it is 100. So that's how the data is available. You cannot go and search for, I need 2,000 images of proliferative diabetic retinopathy. It is highly affected. So we have the data is very much in scarce. That's where GANs have come and they are addressing the problem of generating synthetic data. So anyhow, that is not the interest of the lecture today, but we are talking about the data sets. Okay. So what is the simplicity of the MNIST and fashion MNIST? We need not, when you go for this particular type of task, you need to keep each type of each class of images in separate folders, and you have to call them by saying, if you pick up from this folder, it is normal image. If I pick up from another folder, folder name, you have to specify the folder name. If I pick up from another folder, it is class 1. If I pick up from the fourth folder, it is class, like you have to code. Or you can or another type of coding I have seen is all the images are kept in one folder itself, and there will be a separate Excel sheet showing the labels, and you have to map first image to first column of the first row of the Excel sheet, second image to second row of the Excel sheet. So these and all maybe for a veteran coder, these and all may be very small things, but to deal with the different data sets and to accomplish those, you have one network, better network. It is not like somebody who thinks that you have the neural network code, you have the deep learning code for any data set has to be accomplished. It is not that much simple. You have to write the coding such that the data is mapped with its label. That is what is in fact the supervised learning, which is not a big botheration when you deal with the MNIST and fashion MNIST. And this is what the diabetic retinopathy imaging data set. And then you have a triple IT Hyderabad is having one. So this is a link for the triple IT Hyderabad data set. They have segmentation data sets. So this is classification I told, no, diabetic retinopathy, normal image to diabetic retinopathy, abnormal image. This is one segmentation data set. That is, they have the original image and they have the segmented optical disc also. Okay, so here you have to register with your official mail ID and you can download images. So 50 plus 51. 101 images are there, 50 images for training and 51 images they are kept for testing. In fact, we can modify. When I did my experimentation, I took 80 images for training and 21 images for testing because I already have the code for fetching folders from different, for fetching images from different folders to say these are the training images, these are the testing images. We have the code. And there is one reason why here we have 35,000 images. And for deep learning also, here you have only 100 images. That looks like a very small number. Can anyone say what may be the reason? Because here, if you see, each image is an entity. Each image is an entity. This belongs to class 0, this belongs to class 5. But here, if you see, each pixel becomes an entity. So this pixel is a background. It has to be mapped with the label. Here, what is called as a label? Here, the label is nothing but it belongs to class 1. The label is here is nothing but it belongs to class 5. But here, the label is each pixel becomes an entity and its corresponding label. This particular pixel, it corresponds to background. This particular pixel, it corresponds to the optical disc. Likewise, here each pixel becomes an entity. So the 50 plus 51 images itself is a huge data set here. Okay. In fact, to generate this data set is a big task. The doctor has to clearly map and then the data set is being created like that. So this is a segmentation data set. And just have a look at the cats and dogs data set and have a thought of how it is different from the above data set. There is also another popular data set said to be cats and dogs, which I have not worked. Okay. So I work only with medical image processing. So when I came to know in the Kaggle repository itself, there is a data set like cats and dogs. I was wondering how this will be useful because the major difference being, if you look at the medical images, they are very standardized images. Standardized in the sense 80% of the image is occupied with the eye picture, where here you have the left side, here you have the right side. The optical disc will be there on the right side if it is a left eye, and if it is a right eye, it will be here. These are all very standardized images. But if you look at the cats and dogs data set, the pose of each dog is different, and the pose of each cat is different. Here a hand is there. So this is a big challenging task where the engineers have different perspective to develop networks. Whatever may be the pose of the dog or whatever may be the pose of the cat, it is very difficult to identify. Each has two eyes and the picture having one single head. So it is different to categorize between cats and dogs. So people have that challenge of developing networks to categorize between cats and dogs. Whereas we don't have. If you take a research problem like that, it is your research will move in a different direction. But my research is ultimately identifying efficient features that will classify between diabetic retinopathy classes and to segment the optical disc. How accurately I can segment the optical disc. How I can modify the networks where that can better classify between the optical disc and background. Where we work in this way for very much standardized images. And so I am talking totally about image processing to have a comfort and have a generality that the data science is for everyone, not only for image processing engineers. We can take a look at the tabular data set also. So this is a tabular data set which was developed during the COVID times. So the age, sex, diabetes of a patient, due to the COVID severity, the death of a patient may depend on several factors. We cannot make it on a simple thresholding. See, if it is 76, it is 1. So more than 76 also, some value it may be equal to 0. See, 87 it is equal to 0. So the age is 87. Based on age, it is not linearly related to death and COVID severity because of the several other factors are influencing. Nowhere we can make it linear by simply adding all these things. If I fix a threshold, if it is more than that, death will be there. Less than that, death will not be there. Not there. It is not the case. We cannot take a linear equation. We have to take up a non-linear equation. So how to deal with those non-linear? So these type of tabular data sets in Python. That is also an interesting type of work. So here you have to use pandas and numpy library. So pandas library is more than sufficient. Pandas is a library in Python to deal with tabular data sets, whereas numpy is used only for matrices. So now we are talking about data sets. Let us keep on to that. What is a tabular data set? Na? It consists of the tabulation of different parameters and its label. Okay. So the data set consists of here. It consists of 1603 COVID patients and 13 variables are obtained. 13 variables in the sense 13 features are obtained. And it is available on National Database of Drug Prescription. The database is used in the manuscript. It was published in 2021, Computer Methods and Programs in I have took this paper and we have implemented this. Whereas in this paper they have used the XGBoost. Whereas we changed this also to CNN, convolutional neural network. We have used to implement this particular tabular data set. So we can do one thing. Today we can go for this MNIST classification. One exercise we will do. It is a hands-on exercise. So line by line I will explain the code. So whereas if possible you can try. Otherwise you can simply sit and listen also. Whereas the code and Python installation details I have already shared with Dr. Santosh Kumar yesterday itself. He would have shared the installation details. If you have installed and if you are ready to work with Google Colab, we can go for the experimentation of MNIST. And after that, either we will see, either this segmentation we will see, or this tabular data set we will see. So you can tell at that time. Okay, after we finish this MNIST, another image processing example we can take up, or a tabular data set we can take up. Okay. So what are the different Python libraries? The different Python libraries are NumPy. NumPy is nothing but matrix operations. So you can multiply two matrices, you can divide two matrices, you can take the transpose, you can do any operation on a matrix in MATLAB. So similarly, doing any matrix operations, for that we use NumPy library in Python. And pandas. Pandas is a library to deal with the tabular data set. So definitely we cannot say this as a matrix. A matrix is a set of two-dimensional array which has numbers which doesn't have much meaning. It may be intensity of an image, but definitely it doesn't have more meaning. But here it has better meaning. Better meaning in the sense age, sex, diabetes, likewise. So here also we need to study a lot about what is by qualitative data, what is by quantitative data. Age is a quantitative data, whereas sex is a qualitative data, and diabetes is also. Here everything zeros and ones are taken as qualitative data. So when you are using a CNN, we have to take the qualitative data separately and quantitative data separately and give different pre-processing and treatment for the type of data. Qualitative data has to be treated different way and quantitative data has to be treated different way. It doesn't mean that we cannot combine qualitative and quantitative data to CNN. We can combine, but different pre-processing has to be done. So if the data is quantitative, I hope you can understand better. So still, it is a big, in data science, it is a big study to understand what is qualitative data, what is quantitative data. Some people they simply put it. Some of the students they simply put it that if it is numbers, it is quantitative. If it is not numbers, it is qualitative. Or zeros and ones means simply qualitative. Whereas these means simply continuous numbers means it is quantitative. It is not like that. So domain specific knowledge, again domain specific knowledge is required. Age can be thought of as a quantitative feature because it is somewhat continuous. Because it is numbers, we cannot say this is quantitative, this is qualitative, 0 or 1. 0 is belongs to one class, maybe male. 1 belongs to another class, that is maybe female. So this is a qualitative data. Okay. Diabetes is there or not, it is a qualitative data. Suppose the diabetes values are not given as zeros and ones. Instead, they are given as 0 to 1 as continuous value, 0, 0.1, 0.2, somewhere 0.9 means scaling is given for each patient, and then that becomes a quantitative data. So that's what we have to give different treatment for qualitative and quantitative data. So that's what I started to tell the difference between a matrix and tabular data. So Pandas provides, so Pandas is a library to deal with the tabular data, whereas NumPy is a library used to deal with matrices. High performance, fast, easy to use data analysis to manipulate numerical data and time series data, data manipulation, import and export and analyze best suited for tablet data. So Pandas is best suited for tablet data. What about OpenCV and PIL? PIL is nothing but Python imaging library, whereas OpenCV is open source computer vision library. It is developed by Intel. Okay, so both OpenCV and PIL are used for image processing operations. We have to process the images, we have to resize the image, we have to do histogram equalization. So all these things. So Python being a freeware, like in MATLAB, you can do all the image processing operations all together if you have image processing toolbox. Like there you have toolbox, here you have libraries. Okay, because this is a freeware, we have to import each library in one by one lines in the coding. Okay, import OpenCV, you have to do import PIL, you have to do some of the functionalities in OpenCV also you have to import. Like for example, the code may be like this: from OpenCV import pre-processing. I'm not sure whether it is exactly same or not, but you have to import everything. When you have to first import OpenCV, then you have to import the particular command also in case. So what I'm trying to say now, OpenCV and PIL both are used for image processing operation. These are libraries used for image processing operation. Libraries are nothing but set of commands. Open source computer vision level library developed by Intel, used for image recognition and reading. So whatever can be done by OpenCV can be done by PIL also, and the converse is also true. But we have different libraries developed by different companies. Is a popular Python library for handling and transforming image files. If you look at, if you have a very robust, if you have very detailed coding experience, some of the tasks may be very easy in OpenCV and some of the tasks may be very simplified in PIL. Like we go for Keras and TensorFlow. I have done some bundle of experimentation with the Keras and also TensorFlow. I'm not able to understand between what is the simplicity of Keras and what is the simplicity of TensorFlow. But definitely, certain parts if you do with the Keras, it is very very simple. But some of the operations we want to do, we cannot be done in Keras. We have to go for TensorFlow. In the same piece of coding itself, we can go for the lines with Keras and TensorFlow also in the same Python coding itself. But first we have to import both Keras and we have to import both Keras and TensorFlow. Both we have to import. Okay. When you are building a particular model, when you start building the model in Keras, you have to build the complete model in Keras also. Hybrid models are also there. I will show an example with both Keras and TensorFlow. So before telling what is the library itself, I have given the explanation. Keras and TensorFlow are used for machine learning. So OpenCV and PAL for image processing operations, whereas Keras and TensorFlow are used for machine learning. So this is a machine learning library. Whatever I told now in the morning, training, testing, what is it? Supervised learning. All those type of machine learning operations, developing the convolution layer, max pool layer, building the AlexNet, ResNet. The AlexNet and ResNet, they can be coded layer by layer, and they can also be taken by using inbuilt functions also. Everything has to be done on along with everything has to be done in either in Keras or TensorFlow. And one more is also popular nowadays, PyTorch. PyTorch is a little complicated, but it is more powerful also. So I have not yet worked with the PyTorch, but definitely it is more powerful than some of the operations which needs some 40 to 50 lines of coding in TensorFlow can be done in a single line in PyTorch. Particularly converting all the images to NumPy array. If I want to do that in TensorFlow, it is very, very difficult. Whereas if you take a PyTorch, a single command can easily do that. So that's what. Both Keras and TensorFlow are machine learning library used for data pre-processing images to integer tensors. First, we need to convert the images to values. Images has to be converted to matrices. Okay. In MATLAB, if you read an image, it automatically is converted to a matrix. If you read A is equal to imread of x.jpg. X.jpg is the file name of the image. A is equal to, if you read, finally the A will be a matrix. So here we call that as a tensors, integer tensor. We call that as integer tensors. So TensorFlow is another library used for data pre-processing, which also converts images to integer tensors, and is used to build, train, and evaluate a model. Building a model. What is by building a model? Then this many convolution layers, this many. This is the activation function. This is the dropout layer. So likewise, building the model, training the model, and testing the model, it is useful. So TensorFlow is developed by Google Brain to develop more complex networks. If you have very big network, like ResNet 50 architecture you want to implement without using the inbuilt function ResNet 50 layer by layer you want to implement na, instead of going for Keras, it is somewhat simple to do with TensorFlow. But to learn TensorFlow, it is little complicated compared to Keras. Very excellent courses are there in Coursera. Okay, I will suggest one course also. It's called where you can understand both data science and also implementation using TensorFlow. Okay, so you search in Coursera the basic course in TensorFlow that can be learned. Okay, so I didn't learn Keras. I particularly learned only TensorFlow in Coursera. So automatically Keras also goes hand by hand. And what you need to install when you want to do the work, you have to install Python, Anaconda. When you install Anaconda, you'll be getting something called as a Jupyter Notebook. Jupyter Notebook is a screen where you can type the Python code for execution. And you have to then install Keras, TensorFlow, OpenCV. You are doing image processing operations means you have to install OpenCV. If you are going for machine learning, then you have to install Keras or TensorFlow, or you may be installing both. Okay. So now I'm stopping with only with image processing. Nowadays, image processing won't stand alone. Okay, it is 10 years old project. If you're completely doing with image processing, it is 10 years old project. You have to combine with the machine learning or machine learning AI and all. Then you have to go for Keras and TensorFlow. So these are all the packages you need to install. One simple step is there. Otherwise, install Python and have a user in Google Colab. When you have a user in Google Colab, automatically the Keras, TensorFlow, OpenCV, everything will be getting installed along with the Google Colab itself. You need not separately install. You need to install Python and Anaconda. Python and Anaconda you need to install, and after that take up a user in Google Colab. So automatically you will be having. It is not installed actually, and you will be having the liberty to use Keras and TensorFlow that comes along with the Colab. And what is the other advantage of Google Colab? This is a very simple advantage I'm telling. More than that, the significant importance is when you have a Google Colab user, it uses the Google's cloud servers. I told you some time back, from 100 to 150 images. If I want to increase my number of images, there was so much complexity. But now we are straightforwardly going for 37,000 images. How to deal with 37,000 images? Where I will store the 37,000 images? The Colab gives the cloud servers to store the images, and who will have the computation for handling with 37,000 images? To take up one image and do the pre-processing itself, it requires more computational space. Our laptops are not that much efficient. We are dealing with only CPUs. We need GPUs for all these things. So that is also given by Google Colab. Google Colab gives the storage space and also computational space. It gives the CPU and also RAM. You can leverage the power of Google hardware, including GPUs and TPUs, regarding the powerless of the machine. So nowadays, that's what. So when I want to do some research work, 5 years back, I was thinking about upgrading my machine. So I want this much hard disk, this much RAM. So now I am having a very simple system. But to open the Microsoft Word itself, it takes some time. So that much data is there in the system. Whereas if I want to, I'm working with that same PC to deal with 35,000 images. How it is possible? Only because of the Google Colab. So what is Google Colab? It is another perspective. It is a Jupyter Notebook environment. The Google Colab opens the Jupyter Notebook. Okay. So when you install Python Anaconda also separately without Google Colab also, there also the interface given by Anaconda is the Jupyter Notebook. The Jupyter Notebook is a space where you can type the Python codes. The Google Colab also has a Jupyter Notebook interface installed with Keras, TensorFlow, PyTorch, OpenCV. Okay. In Google Colab, all things will be automatically installed. So you need not another advantage. You need not separately install Keras, TensorFlow, OpenCV. So that will lead to lots of suffering. Okay. So you have installed OpenCV for image processing operations, and then you install TensorFlow for machine learning operations. Finally, only to understand that this particular OpenCV is not supported by this TensorFlow. Okay, particularly this being freeware, lots and lots of problems are there. So it is always advised to go with the Google Colab. So if you are using a Google Colab, the compatibility issues between Keras, TensorFlow, and OpenCV will be automatically taken care of by the Google Colab. Okay. With respect to installation, with respect to commands, we have to only see. Okay. And coming to our first exercise, CNN for classification using MNIST dataset, we are going to see a sample code in Python. So this being our MNIST dataset, how that works in Python code, you will see. So as I told you already, so Google Colab is installed. So Google Colab, you have to take with your Gmail account. So this is my Gmail account for which I have the Google Colab account. So this is Jupyter Notebook. Without Google Colab also, Your Jupyter notebook will be looking like this only, but it will not be opening in a browser, internet browser. Now it is opening in an internet browser because we have Google Colab, and this is the code we have done. So here we have to see connect. When you give connect, it will allocate. It will allocate your space. So you see RAM and disk. Okay. So we cannot use this free Google Colab for industrial purposes and all. For our academic and research purpose, the cloud space offered by the Google Colab is very much sufficient. So RAM is also there, disk is also there. Disk is to store our data. RAM is to do the computations involved by our coding. Okay. So first what we need to do, we need to import several things. We have to import NumPy library to do the matrix operations. From Keras, you have to import the MNIST dataset. So when I talked about MNIST dataset, I didn't do one more thing. The MNIST dataset itself is developed by Keras machine learning library. Okay. MNIST is developed by Keras machine learning library. So we are saying from MNIST, from Keras datasets import MNIST. So whether it is a sequential model or functional model. If you are going for a sequential model in the sense, one layer to next layer, if it is connected, that is a sequential API. This RESTnet is a functional API. If you want to build a functional API, you have to import functional. From Keras, you have to import functional. Sequential API in the sense, it is sequential in the sense it is very clear. The output of the first layer is given to the input of the second layer. Likewise, it goes like a train. There is nothing like a parallel mapping. Like RESTnet is a functional API. So now you are importing. So this importing and all, we cannot take much of the time. So every layer we are importing. Dense layer, dropout layer, even convolution layer also we are importing. So you may be familiar with all these terms, whatever we see whatever we saw in the morning. It is convolution layer. What is a max pool layer? And what is a dropout layer? What is a dense layer? Dense layer is nothing but fully connected layer. Fully connected layer is also called as dense layer. So whatever layers we want to implement, whatever libraries we need to implement, so all should be imported. And then we are giving a random seed to generate random numbers. And this is the simplicity of MNIST dataset. That is, if you give the command as mnist.load of data, it will automatically segregate as xtrain, ytrain, xtest, and ytest. I hope you remember what is by xtrain, ytrain, xtest, and ytest. Xtrain, ytrain, xtest, and ytest. Train in the sense they are training data. Xtrain means that is the data itself. Ytrain is the labels of the data. Label of corresponding to xtrain. For xtrain 1, you have ytrain 1. Xtrain 80, you have ytrain 80. What is train na? It is training data. Test na? It is testing data. Xtest, ytest in the sense the training data's actual data is xtest. Its output is ytest. So we are splitting, and the data set is being downloaded, not to our system. It is downloaded and kept in the Google Colab itself. It is not installed to our system. It is not downloaded to our system. And what is xtrain, ytrain in this particular MNIST dataset? So this is your MNIST dataset. So these are all called as zeros. So the ground truth here is 0. So this is your X train. This is your Y train. Y train. This is 0. I am saying that is my Y train. These are all ones. This is a 1. So I am putting a standard one. Okay. That is my Y train. This is 2. That is my Y train. Which is not shown here. That is what is the simplicity of MNIST. It's not having, we don't have the headache of doing everything. So So 60,000, 70,000 images I told no. So numpy.shape. So shape is one of the functionalities offered by numpy library, which we have already imported. We have imported numpy library. So we can say numpy.shape of extrain. So 60,000 images are used for training. So here we told 70,000 black and white images. So we have used, not we have used. So when you use this command, the code, it automatically segregates 60,000 for training and 10,000 for testing. So what is the first thing now? 60,000 images, each of size 28 by 28. For X test, we have testing 10,000 images, each of size 28 by 28. And finally, we have to say is nothing but the zeros. That is my test. That is my Y train. That is my Y train. So what is the shape of Y train? The shape of Y train will be 60,000 only. Why? 60,000 labels will be there, isn't it? For each picture, 60,000 images are there, no? For each picture, for this the label is 0. For this the label is 0. Likewise, for 60,000 images, 60,000 labels are there. Similarly, Y test. So these things because when we did something, and when something does not work, or we need to download this library, something is commanded like that, then and there we will do. So otherwise, the usual conventional coding methodology will be in the first cell itself. We will import whatever libraries and functionalities that are required. But sometimes when I do the running of next cell, some of the functionalities are not there. So I will insert one more cell and I will do the coding. So likewise. From TensorFlow.keras.details, you could import a load image. So you are combining TensorFlow and Keras to load the image. That is one of the functionality to load an image. And a matplotlib. Matplotlib is another library. So many libraries are there. I have introduced only the basic libraries. Matplotlib is a library which is used to plot the graphs. Import pyplot as plot. So you can use the command called plt. So after I run this, extrain of 60,000, comma, in MATLAB itself, colon, comma, colon means all rows, comma, all columns. So what is the size of extrain? The size of extrain is 60,000. That means 60,000 images are there of size 28 by 28. When I put a colon here and here, it means all rows and all columns. That we know from MATLAB itself. But unfortunately, it shows an error. I'm deliberately doing that. Why the last image we cannot show? When I go for 5,000, the image before that, 5,999. The image before that will be shown. But 60,000, the last image is not shown. Why? Because the Python's indexing starts from 0. So 0 to 100, 100 images are there. Now Python reads it as 0 to 99 only. That's what. And then what we have to do, we are just reshaping. Reshaping extrain dot shape of 0 means what is the meaning of this particular line? Extrain dot shape of 0. What is the shape of extrain? That the first index. Or we have to say in MATLAB terms, we have to say 0th index. What is the shape of extrain? The shape of extrain was 60,000, 28 by 28. Extrain, putting a square bracket, you are saying 0 now, you are referring to this 60,000. Extrain square bracket 1 means you are referring to this 28. So we are just reshaping. 60,000, 28 by 28, we are reshaping to 60,000, 1, 28 by 28 and 10,000, 28 by 28 to 10,000, 1, 28 by 28. We are reshaping to that size. And we are normalizing all the inputs. So this is very much image thing. So those who are done works in image processing, be it in MATLAB also, they know. So whatever is the values, extrain, what are extrain? Training images. What is test? Testing images. So everything you are dividing by the maximum value. So that is simply said to be normalizing. And one more thing, Y train and Y test. There is something called numpy.utilities to categorical. What is meant by that categorical in the sense? When you are dealing with the qualitative data, this is a qualitative data. 9 classes are there. It's a qualitative. Why it is qualitative in the sense it belongs to one class. It is not a value. It is a identity. It is an identity. When it is an identity, it is said to be qualitative. Suppose we are going to meet one physician. We are meeting the physician. They are giving one token. My token number is 12th. I have to go as 12. So that doesn't have a meaning. It is only an index. It is nothing. It is not a value. It is an index or it gives some qualitative information. Likewise, you want to convert that label always when it is classification task, you want to convert that to categorical. Categorical means it means that Y train is qualitative. My Y train is not quantitative. What is by quantitative? Suppose it is marks. It is a mark of students. One student is having 12. Another student is having 100. Another student is having a mark of 90. That is quantitative. That is very much continuous. So if such a label is there, it is not classification. It is said to be regression. In such regression cases, we can have the output as quantitative itself. Whereas when you want to deal with the qualitative data, what we need to do now, you have to convert it to categorical. Y train and Y test have to be converted to categorical. So how many classes are there? 10 classes are there. So I can simply say num class is equal to 10. Why I am saying Y test dot shape of 1? What is the shape of Y test? The shape of Y test will be 10,000 images. Hmm. Here itself it is there. We have reshaped, no? We have reshaped 10,000 comma 10. So Y test dot shape of 1 na shape of 0 means it takes to this index. 1 means it takes to this value. Okay. So how many classes are there? 10 classes are there. So this is what reading the data, reading the input data. If somebody is doing the implementation along with me, let me know if any doubts are there, doubts or problems are there. We'll proceed. We are building the neural network. So now we are coming to the Keras and TensorFlow library. What we are doing now, we are defining a model, convolution layer with the 30 feature maps of size 5 by 5. Okay. So all we will be doing. So we are defining a function file in Python. Model is equal to sequential. This is a sequential model. I told you what is a sequential API and functional API. And model dot add, we need convolution layers. So when you look at a CNN, hmm, when you look at a CNN, it has a set of convolution layers. So this is a standard neural network. This is called as AlexNet. Whereas whatever we are defining here, it is a our own defined neural network. So in our own defined neural network, in our custom neural network, what we are doing, we are having first one convolution layer. How many filters are there? 30. So morning when I told the filters are useful for feature extraction. So I told each particular thing will be having, each convolution layer will be having several filters. Here only one filter is shown, like that I told. So likewise, how many filters we are putting here? We are putting 30 filters, each of size 1 by 1. What is the size of the input we have to share? Say 1 comma 28 comma 1 comma 28 comma 28. That's what when you are working with the Keras, the size has to be given in the reverse. And what is the activation function we are using? ReLU is the activation function we are using. And what is by dropout layer we did not see in the morning. Dropout is, so I'm running this cell also. Let's not waste the time. Dropout is nothing but some of the neurons are lost. Okay. So morning we saw no. Morning we saw the network architecture of a neural network. So when you are going for a deep neural network, so there may be hundreds of neurons in one layer. So to avoid overfitting, what we will do now, they will drop out some of the neurons. The learnings from some of the neurons will be, so learning will happen, but when you are testing, some of the neurons will be switched off. Their impact will be switched off. That is what is said to be dropout. Why they do this why they do this particularly now? To avoid overfitting. Okay, if one person becomes very much eligible for one place only itself now, he will become not suitable for another environment. That's what. That is not a desirable thing in machine learning. So we will switch off some of the neurons. That is what is done by the dropout. and the dense layer. What is by dense layer? Dense layer is a fully connected layer. What is it fully connected layer? I told in the morning convolution layers are useful for feature extraction, whereas fully connected layers are useful for the actual classification. The actual weight tuning and the change of weights and actual learning is taking place here only. And we are telling 120 neurons in the first dense layer and 50 neurons in the second dense layer and the last dense layer. So three fully connected layers we are taking. And what is the important thing to notice in the last fully connected layer? Can anyone tell me? Okay, fine. So here, any number of neurons you can take. In the first dense layer, you can take any number of neurons. But if we go back to our standard neural network architecture, I told this as a three classification problem. Suppose last unit has only three, last layer has only three units. Now it is a three class classification problem. Likewise, we are going to classify to 10 classes. So how many should be there now? 10 classes, 10 neurons should be 10 units should be there in the last layer. So that's what num classes we are given as 10. Here itself we can put a 10, but to make it look meaningful, okay. So if I put 10 here itself, what you can think, what somebody may think here, 128 random selection, 50 random selection, 10 is also random selection, but 10 is not a random selection. It has to be generalized. It has to be specified and generalized. Okay, comma, activation is equal to softmax. So two things to be seen very specifically in the last layer. That is nothing but it has the dense layer has the last dense layer has only the units number of units equal to the number of classes, and the activation function used is softmax only. I told in the morning itself. So when you use layer, when you come to the last layer, here you use the softmax activation function. Whereas here you can use ReLU, here you can use ReLU. After the convolution layer, you can use ReLU. When it were machine learning times, we are using tan H sigmoidal activation functions, but those are ruled out nowadays because of the vanishing gradient problem, as we discussed in the morning. But the last layer ultimately has only softmax activation function. So these two are important things to note. And after that, what is the loss function used to? What is loss is my loss function. You can study it later theoretically. Loss function is nothing but it is the error calculated with respect to single entity. That is for each image we are classifying we are calculating the error. That is said to be loss function. So categorical cross entropy, it is nothing but logarithm of y true minus y predictor. What is y true? Y true is nothing but the actual output, actual label. Y true is actual label minus y predict. Y predict is the algorithm prediction. The difference between the algorithmic prediction and actual label taken logarithm. That is what is a cross entropy. Cross entropy is one of the loss function. Categorical cross entropy, because we are going for classification. We are dealing with the qualitative data. We have to go for categorical cross entropy. And optimizer is Adam. What is by optimizer? Optimizer is nothing but that the gradient dou E divided by dou W. Weight should be adjusted in a direction that error should reduce. So this is a key term. So this is a key term which has to be always kept in mind. Weight should be decreased in which direction? In a direction where the error will be reduced or where the gradient will be reduced. What is the gradient? Gradient is nothing but dou E divided by dou W. That is the rate of change of error with respect to weight. So this adaptive algorithm is one of the algorithms to change it is for weight change. To calculate the weight change, we have Adam. And what is the ultimate metrics? Ultimate metrics is nothing but accuracy. So model is equal to larger model. So we have defined as model. So that we are calling as model. Model.fit. This is a standard coding style. Model.fit of X train to Y train. So this is supervised learning where the X train is fitted to Y train. What is the X train? What is Y train? X train is nothing but each data. What is Y train? This is zero. If you are saying this is zero, that is nothing but a Y train. This actual data is X train. Its corresponding label will be zero. That is my Y train. This is 9, which is X train. I have standard 9, a typed out 9. I'm typing a 9. Okay. Everyone writes 9 differently. So this is the extreme. So the challenge of machine learning task is, the deep learning task is to identify all these strokes as 9. Okay. So in that case, these are all my X train. This is my Y train. So I have to map always X train towards Y train. That is what is called as a supervised learning. And what is validation data? X test, comma Y test. Already we have segregated 60,000 images for training and 10,000 images for testing. We are going to run for 10 epochs of a batch size 200. And then when we run this, so this is the simplest implementation of MNIST, handwritten character recognition. So I told it is a hello world of machine learning problem. That means you have developed some neural network, deep learning neural network, deep neural network, or CNN you have developed. We have to first test it with MNIST. Then only we can go for testing with another data. The simplicity being, the MNIST already has categorized the X train data and Y train data, and the 70,000 images we need not download and keep it to our laptop. The 70,000 images can be there in the cloud itself, directly can be operated in the cloud. And the Y train also we are not able to see. It is class 0, it is class 1. Likewise, it has its Y train already. It has its own training data and testing data also segregated. That is the simplicity with MNIST. You need not. So if you say that I'm only developing algorithms, I'm not bothered about the data. I'm only developing better and better algorithms. Then you can stick on with MNIST itself. Even there are papers that stick on to MNIST only. Okay. So here you have an accuracy of around 98%. So don't look like it is a higher accuracy, because it's only validation accuracy. You have not gone for test accuracy. We'll add one more cell. Okay. That is what is the MNIST classification task. So users can see if there is any doubts, they can ask me. If you have any specific doubts, you can ask. And also you can say me that next, and also you can show me your interest that next we can go for optical disk cup segmentation, or we can go for tabular dataset, you can say. If any specific interests are there, you can say. Yeah, one person has replied as tabular dataset. Otherwise, optical disk cup segmentation is very, very elaborate also. It means a very intensive image processing ideas. So as I have been doing since morning, I can digest it and tell it in a simplified way. No issues for me. I have done in several forums also, but it is as per your interest. Okay. Only one person commented to do tabular dataset. Is there any other interest? Okay. Tabular dataset is very interesting, and it is also generalized, and it can be better discussed in a generalized forum, because a very much image processing idea is not required. That is its simplicity. We don't want, in that terms, we can say we don't want OpenCV or PIL library. Keras and TensorFlow we require. Mr. Sarchana has told us image data set. So only 1:1. Okay, we will go with this code of tabular data set.
ఎందుకు మాత్రం నువ్వేమైనా హే హే అని అవుతున్నా
If anybody wants to do the
పేపర్ ఇస్తావా
segmentation
బాబా
task,
నువ్వు పేపర్ ఇస్తావా బాబా
I think some noise is going on, so they can switch off their mic. Okay, fine. So what I have been telling now, segmentation is little bit elaborate work we have done. So I will not share the code. If somebody is interested to participate in some of the work and they can contribute to, so right now I am writing one paper along with Dr. Santosh Krishna sir also. Unfortunately, we left on the progress of that work as usual 6 months back. So if you want to do the participation in the segmentation based work, you can contact me. So I will give that code. So otherwise, segmentation task I will explain only. Whereas need to spare the code and also the input data. So now we will listen to the tabular data. Okay. So if somebody is very much keen, they can contact me. I will share the video link where I have already explained that optical disc and cup segmentation, and also I will share the code. Okay. If they are ready to do some work and collaborate for paper, they can contact me. So now we will go for tabular data set. So after this lecture, I will share this particular Excel sheet also. So what is there in this Excel sheet? And the corresponding base paper also I will send. So this is patient ID. This is a age, whether male or female. I don't know how being a male or female that decides the death probability. It is also that death probability is also taken only as 0 and 1. So this becomes a classification task, not a regression task. And what is their diabetes? What is their hypertension? And what is their COVID severity? 0, 0, 0. So COVID severity 2, very severe 1. So likewise, the labelings are being given. Similarly, if you look at the age also, they have specified 1 at only 1 point. That means to which age class they belong. So very old means they are specified in age 7. Okay. So likewise, this is a
क्या
data
क्वेश्चंस
set
दिया देख रहा
that
हूँ
deals
भाई जो उसके ऊपर भी
Yes, ma'am. Is someone asking something?
ఇంటర్నెట్ వరల్డ్ వరల్డ్
Yeah,
వైడ్
madam.
వస్తుందా
Lavanya, madam, please go ahead.
కొంచెం బుర్ర వాడు మోకాళ్ళ నుంచి బుర్ర తెచ్చిపెట్టుదాన్ని
So are you talking to here or what, ma'am?
వాట్ ఈస్ W3 ఎవరు ఆన్సర్ చెప్పింది చెప్పండి
Lavanya Reddy, madam, are you talking to me?
No one knows that answer? Shame of yourself. The full form of W3C. The full form of W3C. ఆ క్వశ్చన్ ఉందని కూడా ఆయన చూడలేదు మహాలు ఉన్నారమ్మా
Hello, Lavanya ma'am. Hello.
ఓకే నేను W3 ఏంటి చెప్తాను సి మీరు రాస్తారా షూర్ WWW అంటే That's it. C stands for అది మీరే రాసుకోండి అది మీరు రాసుకో అది మీ ఇష్టం No one is going to write that answer. I'm damn sure about that. తెలీదు తెలీదు తెలియదు రాదు లేదు క్వశ్చన్ చదవండి ఆలోచించండి See, ఏది అది D లాగా కనిపిస్తుందా 3 లాగా కనిపిస్తుందా Hey!
Yes, sir. Tell me, sir. Ganesan, Dr. Ganesan, sir.
Most of the noise are coming.
Professor Ganesan. Yes,
Most
sir.
of the
You want
noises
to?
are there. What is the program?
Yes,
Is
sir.
the
I
this
told the
FDP
moderator.
program? The only one lady is speaking in the classes. They are taking classes with the use of
Yes,
mobile
Bhavani
phone.
Arjun Singh used to come to college. Not in this semester, in previous semester.
Yeah, I have told the
He
moderator
was regular.
to
He
inform
was
her
regular
and
or
cut her
something.
connection.
Why he is not
Someone
coming
can
to
remove
college?
her.
Why he is not coming to college? Any specific reason? Why? I already told you, Sakshi, tomorrow onwards, it's your duty to give calls to girls, right? Otherwise, your grade is going to be decreased. For you boys, okay? Yes, it impacts your CR grading. Clear? And I'm going to create one mail ID. You just put your screenshots in that mail ID, in that drive. Okay? To whom you are calling, what they are telling, I need that entire details to be in that Excel sheet. Clear? Those who are
Okay, I think we are back. And regarding segmentation, if someone wants to work, please contact me. I'll share the code, and also we can collaborate for some work. Write to me at rajachandru82@gmail.com. Now we'll go for working with tabular data sets. So that's what we have been discussing. So I will give the base paper also for this particular code, for this particular data set and particular work. I will share the base paper where the complete analysis of what is the data and what is which are all qualitative data and which are all quantitative data. Everything is being explained there very clearly. So you can have a look at that. And now we'll have this code. Okay. So we are importing the libraries. So as usual, we are importing NumPy, Pandas. So why to import NumPy and Pandas? Okay. Yeah. Why to import NumPy and Pandas in the sense NumPy is a library to deal with the simple matrices, whereas Pandas is a library used to deal with the tabular data set. Okay. If the tabular data set in the sense it is like meaningful data. Okay. So everything is having meaning. Age is a meaning. Diabetes has a specific meaning. Likewise, it is not a matrix. So likewise, if you want to deal with tabular data set, you have to go for Pandas. From math import star for different mathematical operations you have to import the functionalities, import random. From matplotlib import star, so that is for plotting operations. Some from matplotlib.pyplot import to use this particular command. And SK Learn is another library. Like you have numbers, you have already got SK Learn to develop the metrics we have. It's a freeware. So then, like MATLAB, we have different toolboxes. In Python, we have different libraries. So when you click on that, it simply says the explanation for that also. And from sklearn.model selection, import train test split. That means you have to segregate the data as training data and testing data. Okay. So here you have the data. So how much data is there? How many patients data is there? Here we can see. We can see around 1600 and odd 1604 patients details are there. So when you give this particular when you download this particular library, particular functionality, import train tested split. So this is a functionality available in which library we discussed in the morning. We discussed in the beginning of this session as NumPy, what is a library, Pandas, what is a library, Keras and TensorFlow, what library they are we discussed. So likewise, sklearn is another library for dealing with this type of data. Splitting into test data and training data and all, we have this library. And from Pandas, again I am importing data frame, read CSV for reading CSV files and for reading Excel files. Data frame is very generic to deal with data types in tabular data. And next comes the important lines. From Google Colab, import the drive. So my drive I am importing. So what I have done in my Google Drive, I have stored the data. That is, I am connecting this particular notebook, this particular Jupyter notebook to my Google Drive. For that, this is a generic command. Okay, this is required only if you are downloading the data from the cloud. This being a simple tabular, this being a simple Excel sheet, we can have it in the local folder itself. I have stored that in patient data. That has a file called patient data in one of the folders. So I can call that directly also. I don't know whether this is really required. This is usually I do for image processing operations. If it were an image processing operation, what I will do now, in my drive, I have all the images and labels. Everything is taking some times to load. Yeah, if it were an image processing operation, I have the images and labels. See here, I have the images and labels saved in my Google Drive. Okay. So I opened that images and labels also, that folder also, but it is taking time to load. Okay. So that's what. So when you are going for the type of image processing task, it is very, very essential to connect it to your Google Drive. I don't know for this particular code, we have to connect it to Google Drive or not. Is I don't think it is essential. So I'm running the next line. From import to yeah, the previous cell has acted now only. The previous cell, whichever I have run, it is asking whether it can connect to my Google Drive. So I have connected to my Google Drive. Great. Google Drive. I think suddenly internet has become very slow. Just a minute. See here, the RAM and disk that is not connected because of internet connectivity issues. Now ஒரு கோட் மட்டும் ஒரு காமன் நேரம் ஆகும். ஓகேவா?
Raja sir, are you there, sir? Yes, sir.
Yeah, I'll just explain the code. So once you upload that particular file, so it is already run yesterday, and I am just going to rerun only. So
Sir,
what I have been telling now.
sir, your screen is not visible, sir. Raja sir, screen is not visible,
Yeah,
sir.
wait, sir. One minute. I hope it is visible now. Yeah, I have explained these lines, and this particular command imports allows you to attach a particular file. Okay, once you run this particular cell, now it is very slow. It is busily allocating, and once you run this particular lines, these two lines. So Python, this particular Jupyter notebook has the capacity to run the code segment by segment. So once you run this segment, it opens a browse option. So where you can select the file path and you can attach this patient data here. So once you attach that patient data has all these details, and how to deal with this particular file. I'm just giving you the option, and after that you have to read that to a variable name patient data.x describe how the data is statistically available, it is being given. So what is the age, how many patients are there here? 1602 patients are there. And what is the mean age of the patients, and what is the standard deviation, what is the minimum value? Likewise, several statistical information about that particular thing we can see here, and that's what x dot describe. And after that, what you are importing now, you are importing test train split. Okay, and after that, from x you are dropping death and id. Y means you always have x train and y train. So when you look at this particular data, what is my x train and y train? If I ask, what is my ultimate output? The ultimate output we are going to see is the death of the patient, the death probability of the patient, and index also doesn't have any meaning. So when I want to take it as x train, when I want to take it as a training data, I have to eliminate this death and id. That's what is being done in this particular line. X dot drop of death comma id comma access equal to 1. If I give that, so those things will be taken. So what is my capital X? My capital X is actually the X train. And after that, what I'm doing, so similarly I have told this as the X, what the death status, the probability of death is nothing but the Y train. So Y, capital Y I am taking, sorry, small y I am taking X of death. Okay, in the Excel sheet called X is a variable where you have taken the Excel sheet. In the Excel sheet, in that particular Excel sheet, what is my Y train? That is we have taken here. Okay, so y we have taken. So similarly, print y of head. Now what is there in that y that will be given, that will be shown here. Okay, and after that, numpy dot shape of x train. So 1122 patients. So we have seen so many patients, no more number of patients, 1600 patients you have taken, sir. But here only it is showing 1200 now. What is the reason? Because training data is separate, testing data is separate. For training, I have taken 1122 images, each with 22 features. 22 features are nothing but the 22 columns with the different parameters. That's what. But Y, when you come for Y train, there will be only one column. It is only pointing to one label, whether the death probability is 0 or 1. That only we are going to take. So likewise, we have taken we have read the input, and after that we are developing the model. Previously, we have developed one model for that MNIST classification. Likewise, to build the model, several import we have to do. That's what. In conventional coding style, always all the imports will be done in the first cell itself. Everything will import here itself. But whenever the necessity is there, I'm going to code something, some error is shown, this library is not there, that library is not there. If that particular error pops up, we have to import the necessary libraries. So all the necessary libraries are imported here, and the model is being built. What model is being built now? Here we have used Keras, both Keras and TensorFlow. TF means TensorFlow and Keras to build a model. This is a sequential model, and we have, so this is again a custom CNN. It is not a very standard CNN. This is not a very conventional CNN like AlexNet or ResNet. Here we are dictating how many convolution layers are there. 3 convolution layers should be there. So here this AlexNet has 5 convolution layers. Likewise, in the custom CNN, whatever we have coded, we have took these many convolution layers, each with 32 filters, 64 filters, and 128 filters are being taken. Kernel size 3 by 3. What is meant by that kernel size? That kernel size is nothing but before we discussed now. When we are taking the filter, what should be the size of the filter? 3 by 3 filter we have taken. So likewise, we have to code everything. Padding is equal to same. Zero padding we used to say in digital signal processing. Padding in the sense appending some zeros. And what is the activation function? Like ReLU, we have some leaky ReLU. What is by that leaky ReLU now? In ReLU morning, we have seen ReLU we have seen on the positive side only it maintains the same value. 1 means 1, output is 1, 2 means output is 2. Whereas on the negative side it is always kept to 0. So I'm giving some value for that also, that is said to be leaky ReLU. So sometimes the researchers felt that negative values are also important, even though not as much as positive values. Some minimum value was given here. The slope looks like this. So that is what is said to be leaky ReLU. So here we have coded leaky ReLU as the input with the slope. So alpha is some value corresponding to slope. And finally, we are adding some dense layers. Dense layers are nothing but fully connected layers. And units is equal to 2. Why we are using 2 units? It is a 2-class classification problem. Either death probability is 0 or death probability is 1. And activation function should be softmax, which gives the probability maps. And after that, you can compile the CNN with the categorical cross entropy. And like we have Adam optimizer before, we have Ada delta here. So these are different optimizers like stochastic gradient descent, all are useful to reduce the weight change in a direction to reduce the gradient. And what is the metrics we are using? That is the accuracy. So in all these particular CNN tasks, first we have to compile the model. First, this is called as the building the model. Build, compile, and fit. What is by fitting? This model is given input with X train, Y train. What is it? X train, Y train. X train is nothing but all these data. X-train is nothing but all the data, age, sex, diabetes, hypertension. All these values pertain to X-train. And what is Y-train? The corresponding death status is your Y-train. We have to train the model with these data. And what is validation data? X-test and Y-test. First itself, we have segregated the data. Some 1,000 patients are taken for training, and remaining patients are taken for remaining 600 the running in the middle. So that's it. So this is how we code the CNN implementation in for a tabular data set. So that's it. So I will share with Dr. Santosh Krishna this tabular data set code for this tabular data, and also the tabular data set. This Excel sheet also I will share, and the base paper also I will share. Okay. So anyone wants to start work, instead of going for detailed image processing work, you can start your work here. So in the paper, if you read, so much tasking has been done to do the qualitative, treat the qualitative data and quantitative data. Here I have not included all those things. I have not done all those things also. I have just given the guidelines how to read the tabular data and how to fit it to a CNN, which itself is a big task. You can include your own commands for pre-processing the qualitative data and quantitative data. Qualitative data in the sense zeros and ones, quantitative data in the sense continuous variables. So you can treat them and you can extend and you can publish your paper. This is one of the works done in 2021. So I will share all those things. Okay. This is done by some other authors. So we developed the code for some project. And that's it. That's the end of my session. And as I already told you, you can write to me for any doubts in today's session.
If any of the participants
For any
have
doubts
any
in today's
doubts,
session.
please ask, sir. Sir, I guess no one has any doubt. Okay, sir, in the chat, there
Okay,
are
fine.
doubts being asked.
Wait, let me see. Rows sample. I think that message is not visible right now. How much rows do we need as a minimum for text classification model in supervised learning? That's what I told in the morning. So if you want to go for deep learning, how much rows do you need for minimum for text classification? Text classification in the sense you can go for some around 1,000, because if it is, because being a deep learning task, having data less than 1,000 will not help. For text classification with supervised learning, do we need PyTorch, Keras, TensorFlow? No. It is not required. PyTorch, Keras, yeah, it is required. Okay, because we are doing machine learning. We are doing machine learning classification task. We need to have Keras, TensorFlow also. Okay. Either you can work with Keras or you can work with TensorFlow. Because here what we do in the class, what is the model we are using is CNN. If you are not using CNN, if you are using some other classifier, then we can not install Keras and TensorFlow. Keras and TensorFlow are specifically used to build the convolutional neural networks. Because today's topic interest is with the CNN, I have shown the example for classifying the tablet data set using CNN. Otherwise, some paper, even the base paper I am telling, no, this particular data set, tablet data set, they have used the XGBoost, some classification algorithm called XGBoost they have used. If you go for such a classifier, which is very much not dealing with machine learning, then Keras and TensorFlow may not be required. Thank you. Thank you, Ziano.
Anyone else with any doubts?
Hello, sir. Good afternoon.
Yeah, sir.
Sir, is there any possibility to combine the neural network along with the quantum computing? Sir, nowadays quantum computing is emerging. Is there any possibility to combine those two technologies? Maybe quantum neural network, something, sir? Can you please?
Yeah, it is very much possible, sir. Quantum computing combining with neural networks, sir. But the algorithm required to be developed may be little bit different.
Yeah,
that's what. Anyway, I have not explored into those areas, sir.
Okay, sir. Fine, sir. Fine, sir. Thank you, sir. Thank you so much. But there is a possibility, right, sir?
Thank you, sir.
Yeah.
Yeah, there is a possibility, sir.
Yes, sir. Thank you. Thank you.
Thank you.
Okay, so shall we end the session with this?
Yeah. So for any doubts, you can write to rajachandru82@gmail.com. Fine.
Okay, sir. Thank you very much for this session. With this, we come to an end to the 3-day FDP program. Congrats to all the participants, all the online and offline participants. I request everyone in the online meeting to stay there, join us for the valedictory, and all the offline participants can have a 10-minute break for tea and snacks. Thank you very much.
being a friend, but still, easy can
Good evening, everyone.
Good evening,
A warm,
everyone.
a
A
warm
warm
welcome to one more. Is
my name
Niharika
is
Bhattacharya.
Niharika Bhattacharya.
I work from the
I
Department
work
of
from the
Computer
Department
Science
of
and
Computer
Engineering,
Science and
NFC.
Engineering, NFC.
We consider it a
We consider
privilege
it a
to
privilege
conduct the
to
valedictory
conduct the
ceremony
valedictory
for the
ceremony
Faculty
for the
Development
Faculty
Program
Development Program
2023.
2023.
I think that you include
We consider it a privilege to conduct the valedictory ceremony.
B. Rajalakshmi ma'am, HOD of the Department of Computer Science and Engineering, to grace this occasion.
And now I would like to invite Dr. Santosh Krishna BV sir, Associate Professor, Department of Computer Science and Engineering, and also the coordinator of this event to deliver the opening remarks and kickstart the valedictory ceremony.
Very warm greetings from the Department of Computer Science and Engineering to all the participants and dignitaries present here for the valedictory function of the hybrid mode 3-day FDP on AI and machine learning for healthcare engineering. The main purpose of this faculty development program is to share the knowledge of how AI and machine learning helps healthcare sector to improve human health and well-being through engineering approaches. We received more than 160 plus registrations from various parts of the country, such as Tamil Nadu, Karnataka, Kerala, Andhra Pradesh, Telangana, West Bengal, Maharashtra, Chandigarh, Tripura, Punjab, Uttar Pradesh, Delhi, and to name a few. First and foremost, I would like to express my appreciation to all the speakers for the valuable contribution to our faculty development program. I would like to express my sincere gratitude to our Honorable Chairman Sir, Principal Sir, Dean QASDC Sir, and Dean Academics Madam for accepting our proposal and rendering plus support to conduct this FDP. A special thanks to our beloved HOD Madam for the motivation and support in all the stages of this conducting FDP. My deepest gratitude goes to all the online and offline participants for your support and cooperation in making this event a grand successful. Also, I extend my sincere thanks to Istanbul Software Private Limited, Bengaluru, for supporting us by sponsorship. Last but not least, I want to extend my vote of thanks to our organizing team, systems department, supporting technical staff, and student volunteers for making this event a grand success. I would like to conclude with a small verse from Bhagavad Gita, chapter 2. Right knowledge is the ultimate solution for all our problems. I repeat, right knowledge is the ultimate solution for all our problems. Thank you.
Thank you so much, sir. It's been our pleasure to host FDP 2023, and we would like to know how well have our efforts resonated with you. I request anyone among the participants to give us a feedback on our special program. Feedback.
Myself, I'm Anjali from CE department. The FDP was very well organized. Like there was a consistency between each and every session, and both hands-on session and morning sessions were very informative, and we got benefited.
Anybody else?
Anybody else?
Anybody else from the audience?
No, any improvement points you wanted to give?
Maybe they will share it later.
Okay, no, we have.
Sir, our own sir.
So good evening, everyone. Nothing improvement, sir, but I wanted to say congratulations to Santosh Krishna, sir, actually, for making this FDP a grand success. Because he was involving in each and every team, even in the organizing or even in the stage committee. So he was asking everybody, like going there and whether everything is in proper place, whether he needs any inputs or anything to be done. And the resource persons, what he arranged was extremely good, actually. So for that, very thankful to you, sir. And many more to come from CSP.
Thank you all for your very valuable feedback. This brings us to the important part of our ceremony, the distribution of certificates. I would like to invite Dr. Sanjeev Sharma, sir, Dean QASDC, to distribute the certificates. I request the participants to please come forward and collect the certificates as we call out your names.
So we'll stand here.
Starting with Mr. Gokul Raj K. From the Department of Artificial Intelligence and Data Science from Dhanalakshmi Srinivasan College of Engineering. Mrs. Lata S.S., Senior Assistant Professor from the Department of ISC. Mrs. Sovika KV, Assistant Professor from the Department of ISC. Big round of applause.
Only for her?
Mrs. Soumya HK, Senior Assistant Professor from the Department of Artificial Intelligence and Machine Learning. Big round of applause. Mrs. Kaveshri C, Senior Assistant Professor from the Department of Artificial Intelligence and Machine Learning. Miss Anjali, Senior Assistant Professor from the Department of Computer Engineering. Miss Salna Joy, Assistant Professor from the Department of ECE. Navya R from the Department of CSE. Venala M. Reddy from the Department of CSE. Likita Karanam from the Department of CSE. Praveen Kant P from the Department of CSE. Okay, Yakshita KC from the Department of CSE. Dr. B. Rajalakshmi ma'am, Professor and HOD from the Department of CSE and LCE. Big round of applause. Dr. Rachna P, Associate Professor from the Department of CSE. Dr. Santosh Krishna BV Sir, Associate Professor from the Department of CSE and LCE. Dr. Nirmala M. Ma'am, Associate Professor from the Department of CSE and HCE. Dr. Ashok K. Sir, Associate Professor from the Department of CSE and HCE.
And now we have Dr. D. Roja Ramani, Associate Professor from the Department of CSE. Dr. Tejas K.R., Associate Professor, Department of CSE. Ms. Asha Rani Bora, Senior Assistant Professor. Ms. Pramila Rani K, Senior Assistant Professor, Department of CSE. Ms. Sonia Rani S, Senior Assistant Professor, Department of CSE. Mr. Santosh Kumar B, Senior Assistant Professor, Department of CSE. Mr. Manjunatha Swami C, Senior Assistant Professor, Department of CSE. Ms. Subhashri Rath, Senior Assistant Professor, Department of CSE. Ms. Nagamanjula Rani, Senior Assistant Professor, Department of CSE. Ms. Jayashri, Senior Assistant Professor, Department of CSE. Ms. Sri Vidya Ji, Senior Assistant Professor, Department of CSE. Ms. Salangai Nayagi, Senior Assistant Professor, Department of CSE. Ms. Yogita, Senior Assistant Professor, Department of CSE. Mr. Manikanda Kumar M, Senior Assistant Professor, Department of CSE. Ms. C. Chitra, Senior Assistant Professor, Department of CSE. Mr. Bhaskar S.V., Assistant Professor, Department of CSE. Ms. Champavati, Assistant Professor, Department of CSE. Ms. Nayana N. Kumar, Assistant Professor, Department of CSE. Mr. Giluvraj B, Assistant Professor, Department of CSE. Ms. Florence G, Assistant Professor, Department of CSE. Ms. Lakshmi S. Hane, Assistant Professor, Department of CSE. Ms. Priya TV, Assistant Professor, Department of CSE. Ms. M. Anu Mohan, Assistant Professor, Department of CSE. Ms. C. Lavanya, Senior Assistant Professor, CSE.
Okay, you are next.
Thank you so much.
Thank you so much, sir and ma'am. It is said that teamwork makes the dream work. And so, let us thank the team who have made this event possible. I would like to heartily compliment the organizers for the efforts they have put in, for the kind of events organized, and for all the esteemed faculty for the knowledgeable talks given and the participation that they have drawn. We deem it a great honor to propose the vote of thanks on this occasion. On behalf of the QASDC and the Department of CSE and HCE, we would like to express our profound gratitude to our chairman, Dr. Mohan Magnani sir, and Principal Dr. Manjunatha sir for their support to organize the program. We would also like to thank Dr. Sanjeev Sharma sir, Dean QASDC, and Dr. Anandi RJ ma'am, Dean Academics for their support and guidance.
We are very grateful to our HOD, Dr. Rajalakshmi ma'am, for her moral support and guidance. A special thanks to the event coordinator, Dr. Santosh Krishna BV sir, for his expertise and smooth facilitation of the events. A big thanks to our sponsors, volunteers, faculty members, and all the student coordinators for making this event a grand success.
We have now reached the end of the valedictory ceremony. We hope that we have helped our participants in keeping themselves updated with the latest applications of AI and ML in healthcare engineering. Thank you all for taking out your valuable time to be here with us today.
Now, I kindly request everyone to please rise up for the national anthem.
Thank you, everyone. Signing off, here's Niharika.
And Roshan, wishing you a great evening.
Great evening. Okay, I will tell you. One day I'll put that laptop on.
What did I do? Hey, you took pictures, huh?